Welcome to the AWS Certified Data Analytics Specialty training course. Let me briefly introduce myself as an instructor. I have experience in the development, enterprise system, and the cloud architecture for some major companies. Besides this course, I offer tutorial on the cloud services and programming on Udemy and YouTube. I also offer courses to prepare for the other AWS certification exam and tutorial on other cloud services like Google Cloud and Azure on Udemy. This course is dedicated for those who want to pass the data analytics exam. It covers key points that will appear on the exam test and includes about 10 hours of video explanation. It covers all the service within the exam scope, and within the hands-on video, you can engage in the practical learning, and it also provides a sample question for you. And lastly, I hope that you passed your exam and elevate your skill further. Thank you for listening. In the YouTube version of this course, it includes the presentation of services within the exam scope. For more comprehensive course that includes the hands-on and practice tests, please visit my Udemy course. Check the description for more details. So let's start it. And welcome to the AWS Data Analytics Specialty course. This course is divided into the 4 main sections. In Section 1, Understanding the AWS Certification Exam and Preparation. Then I will be going over an overview of AWS Certification Exam and some tips for how to study for it. And Section 2, Introduction to each services. Then I will cover all the services that could come up in the Data Analytics Certification Exam. And Section 3, the practice question. I will provide the insight and the guidance on what to look out for when taking the certification exam. And lastly, in Section 4, Summary, I'm going to introduce the additional learning resources. Alright, let's dive into the Chapter 1. In this section, I'm going to introduce an overview of AWS, the detail of the AWS certification exam, and how to set up the AWS account. First off, let's talk about what AWS is all about. AWS, or Amazon Web Services, was founded in 2006 and has grown to become the industry-leading cloud platform. It began its journey as a service within the Amazon.com and gradually expanded to offer services like virtual servers and storage known as the infrastructure as a service. Today, they boast over 240 different services and continue to grow their market share year after year. AWS offers its services globally. As long as you have an internet connection, you can access their array of the services. Their services are available in the 245 countries and regions, with 32 regions and over 100 availability zone up and running. This is cloud market share. Over the past few years, AWS has held about a third of the global cloud market share, followed closely by Azure and Google Cloud. Since its inception, AWS has consistently maintained its top spot, setting the standard in the cloud industry. AWS certification is highly recognized and is one of the most sought-after credentials in the IT world. Have a quick look at the comparison between the cloud and the on-premises solution. One of the primary advantages of the cloud service is the ease of development via the internet. Also, you pay for what you use, which often means the reduced cost for the user. But the benefits of the moving to the cloud are not just about the cost saving. The standardization at the infrastructure level can also simplify the management. Lastly, for reference, I'd like to mention a comparison chart released by Google Cloud comparing the three major cloud services. All three giants offer similar services. If you had experience in the Google Cloud or Microsoft Azure, this comparison might help you to grasp the AWS more effectively. And for those who are looking to explore not just AWS but other cloud service as well, the document can be quite handy. And next, I will introduce an overview of the AWS certification exam. Before we start, I want to talk about something that might sound a bit preachy: how to learn AWS. If you go online and search for how to study AWS, you will come across comments like, "I passed in just a few weeks," or "I passed even though I am a beginner." But don't take those words seriously, because the way of learning is different person by person. Your background, how quick you grasp things, your home life, your work situation, all these things affect how much time you can dedicate to studying. It's important to find a pace that works for you. When it comes to studying, there is no one-size-fits-all approach to studying. The learning style is different by person, and the time needed to pass the exam is also different by person. And easy and hard are subject and are not universal truths. We all have varying amounts of time we can allocate to study due to work, the family, or other commitment. There is no end to learning in the tech world, and engineered skills are built over time. Engineering skills are built over time and stacked. The IT world is rapidly evolving. There is no end point to learning. Make the most of any free time and find a suitable way to keep learning. Earlier, I told you that the way of studying differs from person to person. In this code, I will be breaking down the AWS services by category, and after that, providing the practice questions. Whether you want to dive into the lecture first, or tackle the question to gauge their difficulty, is totally up to you. Thanks to platforms like Udemy or YouTube, things that used to be company secret is now out there for everyone. With this kind of learning, the technology and the business skills are no longer exclusive company secrets, but have transformed into the publicly accessible knowledge. This means the more willing you are to learn, the more you can grow. The benefit of on-demand video learning includes, as long as you have internet access, you can learn anytime, anywhere. You get to attend lectures by popular instructors, regardless where you are. And it's flexible. You can adjust the playback speed and revisit specific sections. On the other hand, the drawbacks of on-demand video learning include, unlike classroom, it lacks the immersive experience. Because the teacher-student relationship is one-to-many, it's hard to ask questions in real time. So I've incorporated this perspective into the course. And also, video calls can make asking questions hard because there's one teacher for many students. But in this course, I try my best to answer your questions. And here is an overview of the AWS certification exam. There are 3 levels: foundational, associate, and professional. And there are currently no prerequisites for taking the exam, so you can take the exam whenever you want, depending on your experience and skills. Specialty level includes the DevOps, networking, Alexa skill builder, the security, machine learning, database, and data analytics. And this is the top paying ranking of the IT industry. It is notable that there are 3 AWS certifications in the top 10 rankings. Including Google Cloud and Microsoft Azure, there are 6 cloud-based certifications in the top 10. Today, cloud computing is the most important skill for not only infrastructure engineer, but even every IT engineers. If you want to broadly advance your career in the IT industry, it is highly recommended that you study for cloud certifications. The exam format is multiple choice or multiple response. Choose one or more of the options A, B, C, or D. The exam duration is 180 minutes and there are 65 questions, but only 50 actually affect your scores. The remaining 15 questions are used by AWS for research purposes. And the score is a scale score, so the score varies depending on the question. The passing score is 715, and the exam cost is $300 US. This is a content outline for the certification exam. The exam guide provides the weight and the content domain. The correction is 18%, and the storage and the data management is 26%, the processing 24%, analysis and visualization 80%, and security is 18%. And domain 1, the correction, the focus on the understanding the operational characteristics of the correction system, including the data loss, cost, latency, and handling different types of data frequency and format. And domain 2, the storage and the data management, addresses how to select and determine operational characteristics of the storage solution, understanding data access pattern, the schema structure, the data lifecycle, and managing metadata. The domain 3 processing focus on determining data processing solution requirements, designing ETL and ELT for data preparation, and operationalizing data processing solution. And the domain 4, analysis and visualization focus on the understanding the operational characteristics of an analysis and visualization solution, the selecting the right data analysis and visualization for the various scenarios, and understanding the integrated solution. And last, the domain 5 security focuses on the selecting the appropriate the authentication and authorization, applying the data protection and the encryption technology, and implementing the data governance and the compliance controls. And in the last, this is the sample question. As you can see, the Apache open source and the Python framework are included in the question text. So you need knowledge not only AWS services, but also of common frameworks that are compatible with AWS data analysis tools. But don't worry, this course will include the basic knowledge of these frameworks and tools. And next, I will introduce to the creating an AWS account. Many of you may already have AWS account, but I have included it for your reference. And first, I will introduce the tools provided by AWS. The tools for developing and manage application in AWS includes the console and CLI and SDK. And the management console, or simply console, is a tool that allows you to manipulate AWS graphically by a web browser. It is the first page you access after creating an account with AWS, from which you can access various services. And CLI, Command Line Interface, is the tool to control service by a command line. And you can access the AWS environment using an access key and a secret key. And there is also the CloudTrail, which allows you to access the console once and control the CLI from your browser. And this allows you to manipulate the CLI without any prior setup. And SDK, the Software Development Kit, is the tool for developing the various AWS services. It provides the language-specific APIs for each AWS services, such as Python and Go. Then this one also allows you to access the AWS environment with an access key and a secret key. And this is a step to create the root account and IAM user. And first create a new AWS account and then set up IAM user. The IAM or IAM is the service that manages the permission of users in AWS. I will explain it again in the next chapter. And first search AWS in your browser and go to AWS web page. And you will see the button in the upper right corner that said Sign in to the console, and click it. If you already have an account, you can sign in from this page. To create a new account, click the Create New AWS Account. Enter your email address to authenticate your email. A verification email will be sent to that email addresses. And next, enter your personal information such as address, the credit card, or phone number, etc. A credit card is required for your billing, even if your billing is zero. And if you are not belong to the corporation and use AWS for personal development or just learning, I recommend you to choose the basic plan, which is free of charge. And for developer plan and business plan, you can get support from AWS customer engineers. And once you have completed this process, AWS account will be created successfully. And this is a page called the Management Console. This will be the main page when you use AWS resources from now on. And now I'm going to the Configure IAM. The first account that created is called the root user, and it will be the powerful account like administrator with access to your credit card. If the account is compromised, there is a security risk. Therefore, AWS recommends that you create an IAM user and sign in as an IAM user instead of using the root user normally. And first type IAM in the search window above and move to IAM dashboard. And this is the IAM dashboard. In the initial state, the root user has MFA is marked with a red triangle. It is recommended that you install the token apps on your smartphone devices. And the next time you sign in a root user, authenticate with MFA. Next, create an IAM user. The next time you sign in as usual, sign in as this IAM user. You should not sign in as a root user except when checking your credit account. Click on the user in the left menu and then Add User. Set the user name and check the access key and password field for the credential types. The access key is used for the API, CLI, and SDK, and the password is used to sign in to the management console. And select Attach Existing Policy Directory and choose Administrator Access. This will give you the I am user all privilege except the credit card access. Tags can be any text you like. The tags allow identification of I am user. If you create a multiple user in the future, you may set tags to identify each user. And after successfully creating a user, be sure to save the access key and password that are displayed. You can also download this in CSV format. When you have done set up IAM, you will return to the console again, and I will briefly introduce you to the structure of the screen. Now from the menu bar above, you can move to the various management screen. You can return to the top page by clicking the AWS logo on your left. Click on the services to see all the services offered by AWS by category. You can also register frequently used services as favorite. Click on the CLI logo to open CloudTrail. By doing so, you can manage the command line from within your browser as well. And click on the bell mark to view various notifications. You can find out above event, the changes, and the incident for the services you are operating. Now click on the question logo to get the support. The type of the support available depends on the plan. For example, the basic plan allows you to ticket-based question about the fees, while technical support is available with pet plan. By clicking on the gear logo, you can edit the language, the visual mode, and so on. This is recently added features. The menu bar configuration may change in the future. And next, click on the pull down where user region name is listed to navigate to AWS region. The Northern Virginia is selected by default. Basically, by selecting the region that is close to where you want to deploy your services, you can access your resources with low latency. Also, the services deployed and the fee varies slightly by region. Since AWS is a US company, so releases are generally the earliest in the US region, and are then after rolled out the other regions. The documentation and other information is also available in English for the latest services, and is gradually being translated into other languages. And finally, you can check the account information you have created from the upper right corner of the console screen. Clicking on the organization will take you to the AWS Organization Service page, where you can view information about the organization you belong to. From here, you can also check your service quota and usage status, and so on. If you need to access credit card information, you will need to sign out of your IAM user and sign in as a root user. And let's start Chapter 2, Introduction to each services. In this chapter, I'm going to introduce each AWS service that appear on the exam, and I will explain by these domains. And first, I will introduce the recent trend in the data analysis. Since around 2010, the circumstances of the data analysis have been evolving. With technological development such as smartphones, IoT, and nowadays generative AI, the world of data analysis is becoming increasingly complex. The company systems are becoming faster. The business data, such as the CRM, is diversifying. The data formats, such as the batch and the stream and the unstructured data, are diversifying. And the data analysis methods themselves are also diversifying. The demand for the data analysis is increasing in these uncertain and fast-changing times. Now I will introduce the process of data analysis. The series of the steps from the collecting, the processing, and analyzing data is called the data pipeline. And this is the image of the typical data pipeline. Data is collected from the diverse sources, including the company database and the unstructured database. And at this stage, its unprocessed data is called as the raw data. The data can be ingested through the methods such as the streaming, batching, manual upload, or automated integration via APIs. Upon the collection, this raw data is stored in the data lake, a repository designed to store extensive amount of the unprocessed data. The subsequent phase involves the processing the data after process known as the ETL, extract, transform, and load procedure. The processed data is then transferred to the data warehouse. This is optimized for the analysis. For more specific analysis needs, there are the data marts. Once data is appropriately stored, it's ready for analysis using tools and languages, including the SQL and the AI. Additionally, business intelligence BI tools provide a capability for effective visualization. It is important to note that this overview represents the generalized structure of the data pipeline. The definitions and the methodologies can vary depending on the sources and the experts. For example, on platforms like AWS, you can directly execute the queries against the S3 or Redshift. In the initial stage, it's necessary to collect the data from the various data sources, including the diverse range of the data type. There are structured data, unstructured data, and many other data types to consider. Furthermore, there are differences in the data collection timing, such as the batch or streaming. First, let's talk about the data types. The structured data is organized in specific schema or format. It is usually stored in the relational databases. Example includes the data in table with row and columns, where each column has specific data type and purpose, like SQL database. Because of its organized nature, it's relatively straightforward to search and query. Unstructured data doesn't have a specific form or structure. It can be textual or non-textual, encompassing data like emails, videos, photos, social media posts, and more. Unstructured data can be harder to analyze and process compared to structured data because it doesn't fit neatly into tables. The semi-structured data is somewhere in between structured and unstructured data. It doesn't conform to formal structure of data models associated with relational database, but has some organizational properties that makes it easier to analyze. The example includes JSON, XML, and certain NoSQL databases, where data might have the hierarchy or key value pair, but doesn't necessarily conform to fixed schemas. And next, let me introduce the difference between the timing of the data collection. The batch processing refers to the method of collecting, storing, and then processing the data in batches, groups, after a certain amount of data has been accumulated or after a set of period of time has elapsed. The data is collected over time and processed all at once. On the other hand, streaming refers to the method of processing data in real time as it arrives or is produced. The data is processed immediately after being generated or received. Next, I will introduce the data lakes, data warehouse, and the data mart. The data lake is a centralized storage repository that holds the vast amount of the raw data in its native format, including the structured, the semi-structured, and the unstructured data. The data can be stored as is without the need to first structure it. It's designed to scale massively and provides the flexibility to analyze the data using various methods. And the data warehouse is a system used for reporting and data analytics. It is the centralized repository of integrated data from one or more disparate sources. The data warehouse stores current and historical data in an organized manner, optimized for efficient analysis and reporting. The data is typically located into the data warehouse from operational system using ETL, and it's structured often using the star or snowflake schemas. And the data mart is a subset of the data warehouse. It is designed to cater to a particular business area or department within an organization, such as the sales or finance. Think of it as a scaled-down, more focused version of the data warehouse. It can source its data from the larger data warehouse or directly from the source systems. The data mart speeds up the query by limiting the volume of the data to be scanned, as they only concern specific business areas. Next, I will introduce the data processing. The ETL is the typical data processing technique. The ETL is data process that involves the extract, the transform, and load. The extract is the way that data is extracted from the various source systems, such as the relational database, CRM system, flat file, etc. To transform is extracted data is then transformed into a format suitable for the target database or data warehouse. This transformation can involve tasks like the cleansing, filtering, validating, aggregating, enriching, and reformatting the data. The loading is the the transformed data is loaded into a data warehouse or another target system. The ETL is traditionally used with mainly batch processing system, where the transformation happened before loading the data. But with the advent of the powerful cloud-based data warehouses like Snowflake, Google Cloud BigQuery, and Amazon Redshift, ELT has become increasingly popular because these platforms can handle the computational demands of transformation after the data has been loaded. And this is an easy example of the list of names, phone number, email, and age. As you see, the John Bow is duplicated in the name field. In this case, you can choose whether to allow duplicate or eliminate duplications. The phone number has to be numeric data type, but alphabet characteristics are mixed in. In this case, you can choose whether to correct them to appropriate number or exclude them. There are some blank in email address field. You can either eliminate the blank space, leave it as it is, or fill it in with another number. The age field also contains incorrect numbers, which are either correct or left as they are. In this way, when an irregular value is found, rules are applied to convert it to an appropriate form or eliminate it. This is similar to the not null constraint or deduplication process in database. This is a sample of the data cleansing, which is equivalent to transform in ETL process. In actual business situation, the raw data often contains the missing or irregular values. By processing these appropriately, the accuracy of data analysis in later process can be improved. The AWS Glue is used in data pipeline to extract only the necessary data or to transform the extract data into appropriate form and import it. And finally, I will introduce the data analysis and the visualizations. This includes the visualization with BI tool, data analysis, and machine learning. The traditional data analysis often involved using the SQL where clause to specify condition, filtering, and the processing the data. However, the methods for data analysis have become more diverse over time. And recently, the generative AI has become familiar and has impacted our business. The machine learning involves a complex process using the multivariate analysis and statistical mathematics, requiring the specialized knowledge. However, by utilizing the AWS free managed services, you can easily perform the analysis powered by the machine learning. BI, or business intelligence tools, are software solutions designed to analyze and visualize the raw data from various sources, turning it to the actionable insight. They help organizations make informed decisions by providing the clearer understanding of their business metrics and performance. The ultimate goal of BI tool is to enhance strategical, tactical, and operational decision-making across various business domains. And once again, let's take a look at the domain of the exam guide of the data analysis specialty. I have brought the AWS service into the domain. The collection domain includes the Kinesis data streams and the various databases. It also includes the data migration services. And the storage and the data management includes the S3 and the Lake Formation as data lakes, and the Redshift as data warehouse, and the relational database as data mart. And the processing includes the Glue and the Lambda. It also includes the Kinesis for data processing and the Step Function for workflow support. And the EMR, a large-scale data analysis infrastructure, is used to distribute and scale big data clusters. The analysis and the visualization includes the OpenSearch and the QuickSight, as well as Athena and the query service. And the SageMaker is an integrated development environment that supports AI and data analysis. And the security is also required across these data pipelines. IAM provides the identity-based access management, while VPC provides the per-network access management. And the KMS encrypts and secures data. The MESI detects the sensitive data and the confidential data. I will follow details of this process in this course. And next, I'm going to introduce the collection domain. In this chapter, I'm going to introduce the data type and the data format, and the collection-related services including Kinesis, SQS, the managed service for Apache Kafka, migration services, and other services. First, I'm going to introduce the data type and the data format. The structured data is organized in a specific schema or format, usually stored in the relational database. For example, it includes the fixed size data, RDB, CSV, and so on. Unstructured data is flexible data type, doesn't have specific form or structure, such as text, video, and photo. The semi-structured data is between structured and unstructured data, which includes document files such as JSON, XML, or NoSQL database. The vast majority of data generated today is unstructured or semi-structured, especially with the rise of social media, multimedia content, and interconnected devices. It is more challenging to analyze and process than structured or semi-structured data. Now I'm going to introduce data type which you should know and appear on the data analytics exam one by one. Apache AppFlow is a law-based storage format suitable for both serialization and deserialization. It's schema-driven, which means the schema definition is stored alongside the data, making it great for data transport between languages and platforms. A CSV stands for comma-separated values. It's a simple format where each data record is represented by line, and the fields in the record are separated by columns. It's universally understood by many applications, although it lacks a standardized schema. A JSON, or JavaScript Object Notation, is a lightweight, text-based data interchange format. It's human-readable and easy to parse, making it a popular choice for web APIs. Unlike CSV, JSON can handle the hierarchical or nested data structures. The packet is a columnar storage format optimized for big data analytics. It offers efficient data compression and encoding schemas. Integration with many tools in the Hadoop ecosystem and the support for complex nested data structure are among its strong points. The ORC stands for Optimized Raw Columnar. Like Packet, ORC is the columnar storage format. It offers superb performance in the terms of the compression and speed, often outperforming other Hadoop file formats. and is primarily used within the Hadoop ecosystem. In terms of data storage efficiency, typically ORC and Packet are the lightest among these data types due to their columnar nature and advanced compression capabilities. The JSON and the CSV tend to be heavier. The AppFlow can vary in size, but it's usually more compact than JSON and CSV, yet not as light as ORC or Packet. And next, I'm going to introduce the Amazon Kinesis. The Kinesis is one of the important services among data analytics, which includes not only collection domain, but processing and analysis. Here I'm going to introduce all the Kinesis services. In the data collection step, there are two methods, streaming and batch. The streaming sends data quickly, often within seconds or minutes. The batch takes longer, from minutes to days. A batch example is sending sales data daily from a branch to the main office. The streaming, however, is used for things like the video or immediate data from devices. The here elements required for streaming analysis. The data is processed in real time, including formatting, aggregation, and storage, separated by fixed time interval. And analyze the data in real time, and respond to sudden increase in workload. And SQS and Kinesis are services that process streaming data. And when a large amount of data are sent in real time, they are queued once in SQS queue. The SQS is often used in conjunction with Lambda function, which is a scalable event stream function that automatically scales according to the amount of data. The Kinesis specializes in the streaming data processing. The Kinesis is a collection of services that handle the streaming data. In the context of the data processing, the AWS offers Kinesis Data Stream, the Kinesis Data Firehose, and the Kinesis Data Analytics. The Amazon Kinesis Data Streams, or KDS, implement applications that collect and process streaming data in real time. The KDS is scalable and durable real-time data streaming service, which is capable of continuously capturing the gigabytes of data per second from hundreds to thousands of sources. Amazon Kinesis Data Firehose, or KDF, delivers streaming data to data lakes, data store, and analytics tools. The KDF captures streaming data, transforms it, and loads it in S3, Redshift, OpenSearch, and DynamoDB, etc. Amazon Kinesis Data Analytics, or KDA, analyzes the streaming data, get insight, and respond to the business and the customer need in real time. The KDA processes data stream in real time with SQL and Apache Flink. On September 2023, the KDA changed to Apache Managed Service for Apache Flink, but in this course I call KDA. And in the last Amazon Kinesis Video Stream, or KVS, is different from other Kinesis service. The KVS capture, process, and store streaming video. The KVS is outside the scope of the data analytics certifications. And so next I'm going to introduce the Kinesis services one by one. The first one is Kinesis Data Streams. The Amazon Kinesis Data Stream, or KDS, is a free managed service for collecting and processing large volumes of real-time data streams. The streaming data is a continuous data stream consisting of the data blocks of any size, including logs, event, marketplace feeds, the social media feeds, and IoT device data. The KDS is real-time streaming service, which collects data in real time and processes within the stream. This reduces the delay from the time a record is added to the stream to less than a few seconds before processing is complete. The KDS has strong scalability. As data volume increases, the KDS automatically scales up the data stream. This allows resources to be scaled up or down to meet the demand of the application. The KDS is also highly durable. Data can be replicated to multiple assets to ensure data durability and reliability. And the KDS easily integrates with other AWS services such as EMR, Lambda, Redshift, S3, etc. This allows for real-time data analysis, dashboarding, and persistent data storage. And I will introduce the KDS ingestion and delivery of the data. The KDS takes the form of producer-consumer model. When the data is sent from the producer to KDS, the records are split into the data blobs and the partition keys. Based on the partition keys, the data is divided into partition or shard, and shard is a unit of the stream of data. The partition key has the hash value, which determines which shard it will be added to, based on the hash range that each record has. The consumer reads the data from streams. The Amazon Kinesis client library, KCL, makes it easy to build a multi-threaded application to read data from multiple shards in parallel. The records are retained within the shard for 24 hours to 365 days. During this period, consumers can read the same data as many as they wish. The Kinesis data stream offers two distinct capacity modes, the provision mode and on-demand mode. In the provision mode, users determine the number of shards either manually or through an API. Each shard in this mode is allocated with an ingress capacity of 1 MB per second or 1,000 records per second, and an egress capacity of 2 MB per second. This mode cost is calculated based on the number of shards provisioned every hour. On the other hand, the on-demand mode eliminates the need for users to manage or provision capacity. It provides the default ingress capacity of 4 MB per second or 4,000 records per second, and scales automatically based on the highest observed throughput in the last 30 days. For this mode, users are billed per stream per hour and for data in-out per gigabyte. The Kinesis data streams offer a feature to handle provisioned throughput that exceeds exceptions, which occur when the data input surpasses the shared capacity. The underlying causes can include an unsuitable partition key leading to a hot shard. The solution are to either retry with the backup, scale the number of shards, or ensure the use of an effective partition key. The Kinesis producer library, KPL, is a configurable C++ or Java library developed for building efficient, long-running producers. These are KPL's features, including automated retries, synchronous and asynchronous API, the CloudWatch metrics for monitoring, and mechanism for record batching and aggregations. However, it's essential to note that KPL might introduce processing delays up to a user configured setting named record max buffer time. The Kinesis agent is a Java-based agent designed to monitor log files and forwarding them to KDS. The KDS can handle multiple directions and streams, the root logs based on their directory or file, the pre-process data in various formats, and manage file rotation, checkpoint, and retries. It also seamlessly integrates with CloudWatch to offer metrics for monitoring. And then next I'm going to introduce the consumer side. The records in Kinesis are retrieved by consumers, pulling from the shard. Each shard can handle and aggregate the throughput of 2 MB. The GET record API call can return a maximum of 10 MB of data, after which it throttles for 5 seconds, or up to 10,000 records. One shard can handle up to 5 GET record API calls per second, translating to a latency of 200 milliseconds. The KCL, Kinesis Client Library, supports multiple languages, including Golang, Python, Ruby, Node, .NET, etc. The KCL reads records produced with KPL and is capable of de-aggregating them. Within a group, the multiple consumers can share multiple shards, and KCL helps in shared discovery. The KCL uses DynamoDB for coordination and checkpointing. It's essential to ensure adequate provision for DynamoDB's read and write capacity unit, RCU and WCU, or to use DynamoDB's on-demand option. Otherwise, DynamoDB might limit KCL's speed. Data is processed by record processor in KCL. An expired iterator exception indicates the need to increase the WCU. The Kinesis enhanced fanout is the feature which is compatible with KCL 2.0 and AWS Lambda. Each consumer gets a dedicated throughput of 2 MB per second per shard. For example, with 20 consumers, the aggregate throughput would be 40 MB per shard, exceeding the traditional 2 MB limit. The enhanced fanout feature allows Kinesis to push data directly to consumers using HTTP/2, which can help in reducing latency to approximately 70 milliseconds. In the context of the real-time data processing, the KDF is often compared to SQS. And here is the summary of the differences between the KDS and SQS. Both KDS and SQS are used for real-time data congestion and the delivery use case, but for different purposes. As this chart summarizes, SQS is used for asynchronous coordination and decoupling between services. The KDS, on the other hand, is used for real-time data processing. It is not necessary to memorize all the quarters and the numerical information listed here, but it is recommended that you learn about the qualitative uses and purposes. And next I'm going to introduce the Kinesis Data Firehose. The Amazon Kinesis Data Firehose, or KDF, is a free managed service for processing large amounts of data in a short amount of time and in real time, and loading that data into data lakes, data store, and analysis tools. You can easily set up KDF. The KDF is a free managed service that requires very little configuration. You can simply create a stream, specify where the data will send. The KDF supports auto-scaling based on the amount of data. This allows for sudden increase and the processing even under heavy load. The KDF can transform and compress data in real time before storing it in S3, and this reduces data storage cost. KDF supports various data types. Data can be converted to formats such as Apache Packet or Apache ORC before storage. And the KDF has built-in data enrichment and transformation. And Lambda can be used to transform or enrich data to be delivered in KDF in real time. And the pricing is based on the volume of the data. And I will introduce the scenario for the using KDF. The KDF delivers data in groups of certain size or time interval. This increases the efficiency of processing large amounts of data. And the KDF also supports compression and encryption to increase the data security and the transfer efficiency. The KDF also has the built-in Lambda function for flexible data transformation. And the KDF allows for buffering, setting the timing before data is delivered. And you can configure the buffer size for maximum 128 MB and the buffer interval up to 900 seconds. This is comparison of KDS and KDF. The KDS requires user to write custom code for both producers and consumers and offer real-time processing with latency as low as 200 milliseconds for classic and 70 milliseconds for enhanced Farhand. Additionally, KDS requires manual management for scaling, involving the tasks like the shadow splitting and merging. And it also provides a data storage ranging from the 1 to 365 days and support multiple consumers with relay capability. And users can integrate KDS with Lambda to input real-time data into OpenSearch. On the other hand, the KDF is a free managed service, eliminating the need for custom code. And it delivers the near real-time processing with a minimum buffer time, 1 minute to automate scaling. Unlike KDS, the KDF doesn't have an inherent data storage. It's designed for serverless data transformation with Lambda and efficiently routes data to destinations like S3, Splunk, Redshift, and OpenSearch. In essence, while KDS is primarily used when there's need for custom code and real-time processing, and the KDF is ideal for those seeking a managed, automated flow to specific data destinations. And next, I'm going to introduce the Kinesis Data Analytics KDA. The Amazon managed service for Apache Flink, or previously known as the Kinesis Data Analytics KDA, is the free managed analytics tool for streaming data. But in this course, I call it KDA. With KDA, you can analyze KDS and the KDF streaming data using SQL, Python, Scala, and so on. The analysis result can be sent to specified destinations. You can specify the data to be streamed by KDS or KDF as the data source. And this is a sample SQL, and you can use the standard SQL for streaming data so that you don't need to learn new language. The KDA supports analysis for streaming data with standard SQL, and Apache Flink and Apache Beam. And the Studio Notebook is integrated with Apache Zeppelin, which is iterative development environment, which you can use Python, Scala, and SQL. The Apache Zeppelin is open source, web-based notebook platform that enables data-driven, interactive data analysis and collaborative document sharing. It supports a variety of interprets such as Apache Spark, Python, JDBC, Markdown, and Shell. And it integrates into many tools such as Jupyter. The KDA is primarily built based on the Kinesis processing unit, KPUs, and the volume of the streaming data process. The KPU is based on CPU, memory, and intermediate storage. And apart from KPU, you are also built for the volume of the data that your KDA application reads from the source streaming data. And you can save the cost with optimization of code, compressing, and monitoring an alert. They ensure your SQL or application code is efficient to minimize the number of KPUs you need. And before sending data to Kinesis, the compressing it can be reduce the volume and thus the cost of the data processing. And set up AWS CloudWatch alarm to get notified about unusual spikes in the usage or cost. And next, I'm going to introduce the Amazon SQS message queuing service. And first, let me introduce the monolithic architecture and the microservice architecture. The recent trend in the cloud system includes the shift from monolithic architecture to microservice. In a monolithic architecture, the processes are tightly coupled and run as a single service. Therefore, if any one of the processes in the system spikes, the entire architecture must be scaled. Because of the high interdependence among the processes, there is a risk that the failure will affect the entire system. In a microservice architecture, the applications are built as a multiple independent components, and each component executes an independent process as a single service. Therefore, each service can be updated, deployed, and scaled with a minimal impact on the entire system. Amazon SQS, the simple queue service, is a free managed message queue service. It is the oldest service introduced before AWS was founded. SQS is used for loosely coupled and asynchronous connections between systems, such as microservices and distributed systems. If the producer sends a large number of messages to the consumer in a random manner, the consumer may not be able to process all the messages and may overload the system. Therefore, by queuing and waiting for a message, the load on the consumer side can be offloaded. SQS is the most important in the application integration and frequently comes up in the certification exam. SQS is used for loosely coupled asynchronous connections and load reduction purpose in use cases where a large number of requests are sent in real time. It can also be used with Lambda to implement the architecture that set the threshold on the number of the queues that are stuck and trigger event or alerts when the threshold are executed. And here is the comparison between standard queue and FIFO first in first out queues. For ordering, the standard queue offers the best effort ordering. The messages can be delivered in an order different from which they were sent. The FIFO queue offers guaranteed ordering. Messages are delivered in the exact order in which are sent. For delivery, standard queues support at least once delivery. There is a possibility of occasional duplicate messages. The FIFO supports exactly once delivery, ensures no duplicates are delivered. For throughput, the standard queue supports unlimited number of the transactions per second per API actions. The FIFO supports up to 3,000 messages per second with batching or up to 300 messages per second without. The use case of standard queue is a broad set of applications where message order and occasional duplicates can be managed at the application layer. And the use case of FIFO is where the order is critical and no duplicates are allowed, like financial transaction or order processing systems. Next, I introduce the message polling. There are two types of polling, the short polling and long polling. A short polling returns message immediately even if the queue is empty, and this is default setting. The long polling waits for a message to become available for time specified by the message visibility timelap, up to a maximum of 20 seconds. And for response time, short polling is typically faster since it returns message immediately. Long polling might be slower if no messages are immediately available, but can reduce empty responses. The short polling may increase network traffic due to frequent empty responses. The long polling decreases network traffic by reducing the number of unnecessary request-response cycles. The short polling has the advantage of its simplicity, but its disadvantage is lower network efficiency. The short polling is set up by default. If you set up long polling, you need to specify wait time seconds parameter in the receive message request. Short polling is suitable for scenario where immediate response is required, even if its result is empty responses. Long polling is useful for query with a low message volume, or for cost saving in the scenario where immediate response isn't top priority. The visibility timeout is that once the queue is polled, it is not consumed immediately, but is retained for a certain period of time. During this period, messages become invisible to other consumers. Messages are processed from the queue after the users have processed the message. The timeout period can be set from 30 seconds to 12 hours. Example usage of visibility timeout is allow other consumer to replace the message in the case of processing failure, and prevent the duplicate message from being received due to connection failures. A dead letter queue is the queue to get the message that failed to be processed to another queue. Example use case of dead letter queue is to move another queue when a limit of visibility timeout is exceeded, and isolate problematic message to investigate the cause accumulated message during failover. Delay queue is the queue which sets the delay time between when the message is sent to a queue and when it is first displayed to consumer. The use cases of delay queue is to maintain time consistency when user-side application require time to process message, and it is used to when some message should not be processed earlier than others. And here's the comparison chart of delay queue versus visibility timeout. The both are functions that manage the timing of the message processing, but the differences are shown in this table. The definition of the delay queue is the time message is delayed before it's available for processing, and that of visibility timeout is the time a message remains invisible after being read by a consumer. In the delay queue, messages stay invisible in the queue after they are sent for the delay period. And in visibility timeout, once a message is retrieved, it remains invisible to other consumer for the specified timeout period. The purpose of the delay queue is to provide the delay for the availability of the message after it's added to the queue, and that of visibility timeout is to ensure a message isn't processed multiple times by different consumers, and provides the window to process and delete this message. The delay queue is useful when you want to postpone the delivery of all new messages. Also, it is useful in scenario where the consumer might not be ready immediately. For example, if the application on the consumer side requires waiting time for processing or take a long time to start up. And the use cases of visibility timeout is when you need to ensure that once a message is being processed, other consumer cannot process it simultaneously. Or it's also useful if you need the time to process and potentially retry the message before it becomes visible again. The queue policy can be set for SQS queue to allow or deny sending or receiving the queues. Queues can be shared by setting up the sending and the receiving of queue between accounts. However, billing is handled by the account that creates the queue. And this is an example of queue policy. As you see in action period, the SQS send message means that the principal is allowed to send a message to the queue. Since SQS is the service for interworking between the services, the setting queue policy is needed. In practice, it is often the case that authorization errors occur due to forgetting to set the queue policy, so care must be taken. For reference, here is the typical API for SQS. The operations on SQS are to be classified into operation on queue and operation on message in queue. The operations on queue attributes are also possible. Next up is Amazon MQ. Amazon MQ is a message queuing service that mediates the message between different systems. It is used for purposes such as decoupling between systems, asynchronous processing, and offloading on the message recipient side. It has been developed based on the third-party message queuing service like Apache MQ and RabbitMQ, and supports protocols like JMS and MQTT. And for reference, JMS stands for Java Message Service, and MQTT stand for Message Queuing Telemetry Transport. Both are protocols that support message queues. Both SQS and MQ, which I introduced earlier, are message queuing service. SQS is a service developed by AWS. When developing the system on AWS, SQS usually used. On the other hand, when migrating from on-premise to AWS, Amazon MQ is used. SQS can essentially scale automatically and unlimitedly, and MQ guarantees throughput based on the instance type. For systems handling large amount of data, SQS is more cost-effective. After migrating from on-premise to AWS, it is anticipated that one might switch from MQ to SQS. Next, I'm going to introduce the migration services. In this chapter, I will explain the data migration services for large amount of data and the database migration services. The Snow family is a service that uses physical storage to transfer multi-terabyte data. The service also supports the transfer from on-premise to S3 and data export from S3. The transfer can take from 1 week to 10 days. The secure transfer are possible because highly durable devices are used and the data is encrypted by KMS. Please note that the available quota is displayed at different value. For example, the Snowball Edge Storage Optimized shows a size of 100 terabyte, but the available quota is 80 terabyte. So, if you migrate 90 terabyte of data, you need 2 Snowball Edge units. And there will be a question that compare network transfer to Snow family. It can take about 1 week to transfer data by Snow family. So if you want to complete the migration in 3 days, for example, or if your data volume is low, it may be better to transfer the data over the network. When transferring a large amount of data in the terabyte range from on-premise to AWS, it is recommended to use Snow family. Transferring via network not only results in the consuming a lot of time, but also risks the uploading data in complete state if communication errors happen. However, for transferring data around, for example, 10 terabyte, uploading via network might be better choice, especially when there are time constraints or when a sufficient bandwidth AWS Direct connection has been established. I apologize for a small text, but here I've included the calculation example for uploading 10 terabytes of data via Direct Connect. In this case, the transfer time is approximately 30 hours. The transfer with Snow family requires about over 1 week, so if we want to minimize the transfer time, uploading via network might be preferable. When considering actual data transfer, it's essential to consider not just the time, but also data quality and the cost. AWS Transfer Family is a service that allows for data transfer to S3 and EFS using protocols such as SFTP, FTPS, and FTP. It's possible to use either public endpoint or VPC endpoint. The transfer family assumes an IAM role to grant permissions, and you can use session policies. For ID authentication, you can either use AWS Directory Service for Microsoft Active Directory or employ a custom authentication service via API Gateway. AWS Data Sync is a data transfer service that makes it easier to use to automate moving data between on-premises storage and S3, EFS, or Amazon FSx for Windows file server. The data sync is designed to simplify, accelerate, and automate the task of transforming a large amount of data to and from the AWS cloud. It can be used for migration, data processing, backups, and archiving. Data sync is mainly used for migrating from on-premises to AWS cloud. In the context of the migration data from on-premise to AWS, a data sync and a storage gateway are sometimes compared. The both support NFS and SMB and overlaps in the protocols they can use. However, be aware of the differences as the data sync is primarily used for data migration purposes, and while the storage gateway is used to maintain a hybrid on-premise and AWS cloud. The transfer family is primarily designed for migrate data to S3 and EFS and using the familiar transfer protocol like SFTP, FTPS, and FTP. And this makes it suitable for businesses that rely on traditional data transfer method and need seamless integration with AWS. And in contrast, the data sync offers a fast and simplified solution for online data transfer. It automates the process, ensuring the data is moved quickly between on-premise, S3, EFS, and Amazon FSx. The data sync is optimized for migrating large amount of dataset over the network, making it efficient choice for continuous data replication and timely dataset migration tasks. On the other hand, the Snow family is useful when dealing with bulk data transfer, especially when the network bandwidth is weak. So the Snow family uses the physical storage devices like Snowcone and Snowball to securely transfer large volume of data, eliminating the need for network protocols. It's useful in situations where transferring data over the internet would be too slow or expensive, or where connectivity is limited. In essence, while the transfer family and the data sync provide online solutions that leverage network protocol, the Snow family offers an offline, physical approach to data migration. And next, I'm going to introduce database migration services. The database migration service, DMS, is a service help users migrate their database to AWS with minimum downtime. It supports both homogeneous migration between the same database and heterogeneous migration between different types of database. And DMS is primarily designed to streamline database migration, making it more accessible to transfer data from on-premise to AWS and vice versa, or from an AWS RDS instance to another. AWS Schema Conversion Tool, SCT, is designed to convert schema and build between different database engineers. While DMS does not support schema conversion by itself, when working with the same database engine, you would use respective management software. However, for conversion between different database engines, the SCT is essential. SCT can be installed on a various client operation systems, including Windows and Mac. It not only converts database schemas, but also reads from the data transform code, such as views, stored procedure, and functions. SCT serves as a tool to convert the schema information, including columns, table, indexes, and constraints. Essentially, it aids in migrating the shape of the box of database. On the other hand, DMS is employed to migrate the content inside the box. To give you a cleaner image of SCT, I'm going to introduce the example of schema conversion and stored procedure conversion. Here we are focusing on the schema conversion from a Microsoft SQL Server to Amazon Aurora's MySQL compatibility. This image shows the conversion of the table schema. In this conversion, the identity has been changed to auto-increment, and the data type of price has been converted to decimal. Due to different data types and keywords available in Microsoft SQL Server and MySQL, this conversion is necessary. And next I present the example of stored procedure. As a case for the stored procedure, consider adding a new product to product table. Unlike SQL Server, where parameter names is required presenting @mark, MySQL doesn't need it. Also, the conversion of parameter for data type is necessary. The declaration and the termination of procedure differ too. However, sometimes SCT doesn't fully support specific data types engine. In such scenarios, you need to manually convert the schema. Now, I have summarized the main AWS migration services and when they are released. In general, the more the recently released services tend to have the richer features and offer comprehensive support for the migration process. AWS Import and Export and the VM Import and Export, which were released around 2009 to 2010, are now seldom used. When it comes to certification exam, you may find in older documents still include VM Import and Export. But those who planning to use AWS from now on, it would be sufficient to familiarize themselves with the service released after 2015. Lastly, I'm going to introduce Data Exchange and AppFlow. AWS Data Exchange is a marketplace service that allows you to search, subscribe, and use over 3,000 datasets. You can subscribe to the data from provider, store it in S3, and connect it to your analysis tools. You can select a catalog from the console screen, retrieve the data via Data Exchange, and utilize the data. The usage prices vary between data provider and subscriber. You are charged with subscription and the amount of data. Amazon AppFlow is a free managed integration service. AppFlow facilitates the secure transfer of data between AWS and the cloud-based applications, allowing users to move data across different sources without writing code. And here are the key features of AppFlow. AppFlow is free managed, so you don't have to plan resource or provision for large dataset, and auto-scaling is supported. AppFlow is a no-code service. You can easily map and transform the data. When it comes to the security, the data are encrypted at rest and in transit. AppFlow also supports private link, enabling users to transfer data entirely within the AWS network. And you can set up flows to run at a specific interval or in response to the business event, like a new record being added in the Salesforce. In the context of the data transfer between services, let's compare the data pipeline and AppFlow. The data pipeline orchestrates the data-driven workload and moves the data between AWS services. On the other hand, AppFlow creates and manages data flow between SaaS application and AWS. However, the data pipeline is not available in some region and will be discontinued, so you will no longer need to run it. Data pipeline is currently under maintenance mode and not accessible from the console. It has also been announced that it will not be deployed to new region. Currently, access is limited to CLI or via API. We have no official announcement whether or not data pipeline will be discontinued completely, but from a practical standpoint, we should look for other alternatives such as Step Function or Apache Airflow. And next, I'm going to introduce the storage and the data management services. In this chapter includes Amazon S3, which is the most popular object storage service, Lake Formation, and database services. And firstly, I'm going to explain the data type and the storage services. We have object storage, block storage, and file storage. In the world of data analytics, the object storage is widely used. The object storage has no hierarchical structure and data is stored in a flat address space. And each data has a unique ID, and when accessing the data, the ID or metadata is searched. Because it can store both structured and unstructured data, it is used in a wide range of the use cases. This image shows storage services according to the frequency of the data access. The services on the left are more suitable for frequently accessed data, while those on the right cater to less frequently accessed data. While relational database sits in the middle, NoSQL database offer quicker access, and the in-memory databases are the fastest. In contrast, the Redshift takes more time to retrieve data. The S3 is versatile, spanning all the range because it provides a storage class for a variety of use cases. And next, I'm going to introduce S3. Amazon S3 is a general-purpose object storage service. It is widely used in many use cases. It is highly durable, has unlimited capacity. In the context of data analysis, S3 is used as a data lake because it can store structured and unstructured data. You can also use Athena to directly query and analyze data stored in S3. You can store large amounts of data in S3. On the other hand, you need to consider access control, data encryption, cost control, and many other things. S3 has storage classes as listed here in the table. The standard class is selected for frequently accessed data. The standard IA, or infrequently accessed, is used for the less frequently accessed data. The ones on IA is replicated only within a single availability zone and is less expensive due to less redundancy. Intelligent tiering migrates data to lower storage classes based on the access frequency. And Glacier is used for archived data that is referenced less frequency. Both have 11.9 durability. On the other hand, availability varies by storage classes. And you can set lifecycle management to move data that has not been accessed for a period of time to another storage class, or delete it. Amazon S3 Glacier is used for backup and archiving of infrequently accessed data. It is less expensive than S3. and you can configure lifecycle management between S3 and Glacier. The Glacier has three classes: the Instance Retriever, the Flexible Retriever, and the Deep Archive. The Instance Retriever is used for the access multiple times per year, the Flexible Retriever for access about once a year, and the Deep Archive for access less than once per year. The retrieval speed can be optionally set to expedited, the standard, or bulk. Next, I introduced access control. There are three methods of access control: IAM, bucket policy, and ACL. The IAM provides the identity-based access control. You can define the IAM policies and attach them to IAM user or IAM roles. The bucket policy provides the access control on bucket basis. The bucket owner can set access permission for other accounts. You can also control on object basis by including the object name in the resource attribute. The ACL provides both bucket-based and object-based access control. The bucket ACLs are rarely used because they have the same use area as bucket policies. The object ACL are used by object owner to control the access to their object. But now it is recommended to use IAM policy for ID-based management and bucket policy for bucket-based access control. The ACL are the oldest access control method, and you cannot fine-tune with ACL. The S3 bucket policy provides more fine-tuned configuration than ACL. ACL just grants the read, write, and the least permission to object and bucket. The bucket policy provides the conditional policies, for example, such as only allowing the access from a specific IP addresses. The what can be configured in ACL can also be configured in the bucket policy. However, the reverse is not true. Therefore, it is sufficient to use only bucket policies. And this is the sample policy described in JSON format. This sample policy enforces encryption on upload. In the condition field, the encryption by server-side encryption is defined. If you want to use KMS, you change to AWS:KMS. And the next, the signed URL is the URL endpoint that sends an expiration date on an object and can only be accessed through the URL. By using this, anyone who knows the URL can access the object, even if they are not IAM user. On the other hand, if the URL is compromised, there is a risk that anyone can access it. The signed URL can be generated for upload as well as download. This is a sample signed URL. It includes the access key ID, signature, and the expiration date. And next, this is the encryption of data at rest. There are two types of encryption for data storage, and server-side and the customer-side. The server-side encryption involves uploading the data to S3 and then encrypting it, while customer-side encryption involves uploading the data to S3 prior customer-side encryption and then storing it. There are three types of server-side encryption: SSE S3, SSE KMS, and SSE C. In SSE KMS, the encryption and the decryption are executed using KMS. Furthermore, KMS has AWS managed and the customer managed. And in SSE C, encryption is executed using key provided by the customer, and in this case, the key is not stored in AWS. Please remember the type of key, where the key is stored, and who manages the key. Again, for CSE, the AWS is not involved in any way in the encryption and decryption of data, as the data is encrypted on the customer side and uploaded to S3. And next I'm going to introduce the CORS, the cross-origin resource sharing. When reference the content from another domain, the access permission must be granted to the domain. If CORS is not enabled, the blocked by CORL policy error will occur. And this is an example of CORS. In a web application, when the index file is in domain 1 and the CSS file is in the domain 2, it's necessary to enable resource sharing between domain 1 and domain 2. And this allows the index file in domain 1 to reference the CSS file in domain 2. And this is an example of a policy which enables CORS described in JSON format. And next I will introduce the object lock. The locking an object means that object cannot be modified or deleted. In other words, it can be read-only file. To enable object locking, you must enable during bucket creation. The versioning must also be enabled. There are two types of object lock, the governance mode and the compliance mode. Governance mode, which allows changes only to specific IAM user, and the compliance mode, which denies the changes from all users, including the root account. The data stored in S3 Glacier is called an archive, and the location where the archive is stored is called vault, which corresponds to the bucket in S3. Locking vault means the data stored in the vault so that it cannot modify or delete it. It is also possible to lock the policy itself so that it cannot be changed. Next, I'm going to introduce versioning. By enabling the versioning, objects from previous version can be retrieved. In other words, even if you overwrite and save, you can still refer to the previous version of the object. With versioning enabled, if you delete an object, the previous version of the object will remain. The delete markers can be created for object. Accessing an object with the delete marker will result in 404 not found error. To completely delete an object, use delete object version to delete the object including its ID. The versioning can be enabled on the bucket-by-bucket basis. The object, the storage in S3, that has the key and ID. If the versioning is enabled, a put object request or upload object will overwrite the object with same key. On the other hand, the different versions have different ID, so you can refer to them as separate objects. To upload the large data, you can use multi-part upload option. S3 multi-part upload allows for efficient uploading of a large object. It divides an object into multiple parts and then reverts back to the original object when the upload is complete. It also allows retrying of interrupted process. You can configure to delete incomplete multipath upload to prevent being charged for incomplete data as well. You can specify the parameter shown in this table. And the next, S3 Select. S3 Select provides the functionality to extract the data using SQL queries. It supports CSV, JSON, and the Apache packet as data format. You can execute query from the CLI, SDK, or management console. For example, if you have a large amount of data, it takes a lot of time to retrieve the entire data with GET object. The S3 Select can be useful to reduce download time by using SQL to filter only the data you need. S3 dist.cp or S3 distributed copy is a tool to help users efficiently and quickly transfer large volume data between S3 and EMR, or between two S3 buckets. It's an extension of the dist.cp tool provided by Hadoop that is optimized to work with AWS infrastructure. S3 dist.cp divides the source data into chunks and copies multiple chunks simultaneously, leveraging the distributed processing power of the EMR cluster. It can compress and decompress data on the fly during the transfer. And these are the commands of S3 dist.cp, which send the data from S3 to HDFS and from HDFS to S3. Next, I'm going to introduce Lake Formation. AWS Lake Formation is a service that simplifies the process of setting up, securing, and managing data lakes. A data lake is a centralized repository that allows business to store structured and unstructured data at any scale and analyze it using different analytics and machine learning tools. Lake Formation streamlines the process of defining where in S3 the data should be stored and automates much of the processes of the data ingestion. With the Lake Formation, you can prepare data for analytics by deduplication, cleansing, and transforming data. The Lake Formation integrates with IAM and extends capabilities, offering more granular data access controls. And this means you can set permission at the table or column level, not just at the broader bucket level. As data is ingested into the data lake, the Lake Formation catalogs it, transformation raw data into more discoverable and queryable form. In Lake Formation, the data ingestion procedures are built using the blueprint. When you create a blueprint, a workflow for data ingestion, composed of a glue crawler, jobs, and triggers is automatically set up to import data into S3. You can set access permission to data location for principals. Additionally, you have the ability to grant permissions for creating or editing the database and the tables. In Lake Formation, you can set access permission at both the row and the column level. For instance, you can configure permission to allow access only to the row where the place is B, and additionally, you can establish the access permission at the cell level. And next, I'm going to introduce Amazon Managed Streaming for Apache Kafka. Amazon Managed Streaming for Apache Kafka, or MSK, is a free managed service that enables you to build and run Apache Kafka in AWS. Apache Kafka is a distributed processing platform for processing large-scale streaming data at high speed, retrieving and storing and processing streaming data in real time. MSK is a free managed service, so you can focus on creating a streaming application without the operational overhead of automatically providing and maintaining Apache Kafka clusters, Apache Zookeeper nodes, and more. MSK is easy to set up and use. Apache Flink, an open-source streaming processing framework, can be used on MSK. You can write the application of Apache Flink in standard SQL, Java, and Scala. It scales automatically according to the amount of streaming data. You can deploy on VPC, and by IAM, you can configure ID based across control. Also, configure encryption data at rest and in transit. MSK is charged with the broker instances and storage. The larger the data size is, the higher the fee. Apache Kafka is a producer-consumer-based message queue service. This is an architecture of Kafka. The Kafka is highly scalable and can process large number of messages. The messages sent by producer are distributed across the brokers, which allow for processing a large amount of data sent in real time. You may notice this architecture is similar to SQS. In the following page, I will explain the differences between Kafka, SQS, and MSK. This is a comparison chart summarizing the difference between Amazon MSK, the Kinesis, and SQS. Both MSK and Kinesis can process large amounts of streaming data in near real time, so the use case and functionality are similar. MSK is a service that makes Apache Kafka available on AWS, so it features Kafka-specific functionality and APIs. The Kinesis is an original service provided and supports high scalability and auto-scaling, take advantage of the cloud characteristics. SQS will most likely be used for the purpose of asynchronous isolation and decoupling of applications. The throughput of SQS is lower than MSK and KDS. As I explained, MSK and Kinesis are very similar, but some differences. I'm going to introduce the usage scenario for MSK and Kinesis is as follows. MSK is highly customizable. Apache Kafka has advanced configuration options that are useful when the environment needs to be fine-tuned for specific use cases. If you need long-term retention of large amounts of streaming data, MSK is a more suitable option. MSK retains message for an expanded period of time, 7 days by default. This allows the reprocessing of historical data. And when multiple consumers need to consume data, MSK is suitable. The Kafka's consumer groups allow multiple consumers to read data from the same stream. And if you need the integration with other AWS services, the Kinesis might be a better option. The Kinesis can be integrated with other AWS services such as Lambda, Redshift, S3, and is useful for automating data pipeline of collecting, processing, and then analyzing data. The Kinesis is suitable when real-time analysis is required. The Kinesis data analytics can be used to perform SQL query in real time against the collected streaming data. The short-term data retention is acceptable. The Kinesis Data Analytics provides 24 hours of data retention by default, extending up to 365 days. And next, I'm going to introduce database services. First, I'm going to introduce overview of the AWS database service. And first, let me introduce the types of database. The conventional table type database are called RDB or relational database, and generally known as Oracle, MySQL, and etc. And the relatively new types of data format is called non-relational or NoSQL. And NoSQL includes services such as the key value, the document, and the graph types. Here is the list of databases provided by AWS. The Aurora and the RDS, Redshift as a relational database, the DynamoDB as a NoSQL, the ElastiCache and the MemoryDB as an in-memory databases, and the DocumentDB as the document-oriented database, and so on. I will describe the general benefits of migrating your database from on-premise to AWS. The AWS database offers free managed support for patching servers, operating systems, and the database management system, as well as backups and snapshots. In other words, the customers do not need to manage infrastructure or servers. For example, on-premise, when a large number of requests are sent, the customer must manually build more servers. This requires a lot of overhead, but in AWS, you don't have to worry about it. Also, it takes a lot of time to update the version of database management system. In terms of minimizing the management overhead, AWS has an advantage over on-premise. And with AWS, you can easily create a high availability architecture. Imagine having a physical server in multiple locations on-premise. It requires a great deal of man-hours. But with AWS, you can build a master and a replica or master or standby server with just a few clicks. If a failure occurs on the master, the standby server is automatically promoted to the master server. The AWS also supports synchronous replication and automatic failover. And in terms of performance, AWS database services support read replica. You can create read replica across the regions. And in addition, it integrates with reporting and monitoring tools such as CloudWatch, the CloudTrail, and the Cloud Logging. AWS supports many security features such as encryption at rest and in transit, and access control by IAM, and the advantage of the pay-as-you-go pricing. And next, I'm going to introduce each database services. The first one is Relational Database, RDS and Aurora. Amazon RDS is the most popular relational database service. It supports Amazon Aurora, MySQL, PostgreSQL, Microsoft SQL Server, MariaDB, and Oracle. The Aurora is a database engine developed by AWS. Since Aurora can be used as an engine for RDS, the RDS and Aurora have much in common. The storage type available are EBS, general purpose, and provisioned IOPS SSD. And for availability and performance, and multiple availability zone configuration is available. The read replicas can also be provisioned to improve read performance. When the primary instance fails, the lead replica can be promoted to the primary instance. The lead replicas are often appeared in every certification exam. The lead replicas not only reduce the load on the instance, but also provide a failover architecture by promoting the lead replica to the primary instance in the event of failure. The RDS supports several security features, and for network security, you can configure security groups in VPC, and for encryption, not only data in transit and rest, but also backups, storage, and logs. And several types of authentication are supported, such as IAM, the operation control, the Kerberos. And for logging and monitoring, you can use CloudWatch and CloudTrail. The RDS supports automatic backups and manual snapshot. It supports automatically backups once a day and retain for up to 35 days. And transaction logs backup once every 5 minutes and can be restored at any time. You can make a snapshot at any time and retain up to 100 snapshots. And you can also make point time recovery. Backtrack, backup, snapshot, and point-in-time recovery are methods of restoring the database to a specific point in time. Backtrack rewind, while the backup, snapshot, and the point-in-time recovery restore data to a specific point in time. The backtrack rewinds the database for up to 72 hours. The backtracking returns to the database to a specific point in time based on the changed record. There is no need to recreate the database, and the recovery time is shorter than backup. On the other hand, to backtrack database, it is necessary to temporarily stop processing the database. The RDS supports backtrack, but only for Aurora with MySQL compatibility. Amazon Aurora is a database engine developed by AWS. It is compatible with PostgreSQL and MySQL, and it is set to have higher performance than MySQL and PostgreSQL. The Aurora offers a 99.99% SLA and multi-region RTO and RPO in less than a minute. The Aurora offers high scalability and resiliency. The Aurora creates up to 15 replicas to handle a large number of requests. It also achieves a processing delay of less than 10 milliseconds for replicas in response to a request. The Aurora takes advantage of the cloud, allowing a single database to operate across multiple regions without performance concern. The data volume can scale from 10 GB to 128 TB. And next I'm going to introduce the Redshift, the data warehouse service. Amazon Redshift is a free managed data warehouse that can store and analyze the petabytes of the data. It provides the high computing power with a low latency for big data analysis and business reporting. Redshift is highly scalable, so you can store and analyze data ranging from terabytes to petabytes. It's cost-effective and you don't have to pay upfront cost, and it's pay-as-you-go system. The fast query execution using columnar storage, data compression, and distributed execution. For security, Redshift provides high security through deployment, encryption, and access control within VPC. The AWS automatically performs operational tasks such as backups, patching, and recovery from node failures. And you can easily integrate with other AWS services such as S3, RDS, and DynamoDB. And also you can use the standard SQL so that you don't have to learn new language for data analytics. The Redshift is the one of the most important analytical tools in the context of the data analytics. It is frequently questioned on the certification exam. And this is an architecture of Redshift. The architecture is composed of the collection of nodes referred to as a cluster. Within a cluster, there are two types of node, a leader node and a compute node. The leader nodes manage the query coordination and directing query to appropriate compute node. When a query is issued to Redshift, the leader node passes and develops an execution plan to carry out the query. It then coordinates the compute node to run the query in parallel. The leader node also manages the distribution of data among compute nodes. On the other hand, the compute node stores the data and execute query components that the leader node assigned. Each component node has its local storage and operates in parallel with one another. The data within the compute node is organized into the slices. Each slice is essentially a portion of the node storage, and each slice processes the portion of the query. The number of the slices is determined by the node of the Redshift cluster. Generally, disk input and output account for 60 to 80% of processing time in database search operations. Therefore, DWS achieves high performance by reducing disk I/O. And Redshift stores its table by column rather than by row. The columnar storage makes it easy to compress data, leading to storage savings and boost query performance. The 13 types of encoding are available for Redshift. And Redshift offers various techniques to improve the processing efficiency. In order to utilize the zone map, the data is stored to improve searchability. As shown in this image, search efficiency is increased by dividing the data into multiple zones and skip unnecessary zones based on the maximum value of each zone from the minimum value. The tables in Redshift are distributed to each node row by row for parallel processing. You can select the distribution type according to the amount of data and the content of the query. There are three types of the data distribution, and key, even, and all. These distribution types are automatically determined by machine learning. In the key distribution, rows are distributed across the slices based on the values in the columns, which is the distributed key. This is beneficial when you often join tables on the distribution key. Redshift can perform the join locally within a node without needing data shuffling across the node, and this can lead to faster query performance. In the even distribution, rows are distributed across the slices in the round-robin way, without considering the value in any specific columns. This is default and works well when there is no clear join pattern or when the table isn't involved in joins. very often. It ensures an even distribution of data. And for all distribution, a full copy of the entire table is distributed to every node. And this ensures that any join with this table can be done locally within a node. And this is effective for relatively small lookup tables that are frequently joined with a larger table. However, it consumes more storage as it replicates the entire table on each node. In data warehouses that process big data, high-speed parallel distributed processing is used. This is called MPP, Massively Parallel Processing. MPP database use a distributed system to process data and execute database queries in parallel across multiple nodes. The MPP systems break down the task into the small subtasks and distribute them to compute nodes to be processed concurrently. This parallelism accelerates query performance, especially on large datasets. The key, the even, and all distributions support MPP. The Amazon Redshift supports shared nothing architecture. In Amazon Redshift architecture, each node operates independently and has its own local disk storage, where it stores a portion of the entire dataset. The dataset is distributed across the node, ensuring the parallel processing when executing queries. The leader node coordinates the query execution and gathers the result from the compute node to return the final result to the client. This shared nothing approach allows Redshift to achieve high performance by processing the query in parallel across all the nodes. The counterpart concept to shared nothing is shared storage. In shared storage architecture, the multiple nodes share access to common pool of storage. A Redshift uses the concept called workload management queues to manage the query execution. Each queue has dedicated memory and a certain number of query slots. Under normal circumstances, the queries are routed to queues based on the WLMs, the configuration. And when a SQA is enabled, the Redshift uses separate, dedicated memory, the queues for short-running queries. This queue is in addition to the regular WM queues. The SQA can reduce the response time and simplify workload. And next I'm going to introduce some scaling features of Redshift. Both elastic resize and concurrency scaling are features of Amazon Redshift designed to enhance the platform flexibility and performance. The elastic resize is designed to quickly add or remove nodes in your Amazon Redshift cluster, enabling you to adapt to your workload requirements more fluidly. During the resizing process, the cluster is read-only for a short period, but it returns to writable state much quicker than with classic resize. The elastic resize is useful if you have predictable workload spikes and need temporary additional capacity. On the other hand, concurrency scaling handles the high concurrency situation by offloading read quality new transient clusters, ensuring a consistent performance even when numerous queries are submitted simultaneously. The concurrency scaling uses the transient cluster that handles the overflow of the concurrent read queries. These clusters have the same data as the main cluster. The concurrency scaling is easier for environments where there are unpredictable spikes in concurrent read queries. The RA3 instances allow Redshift to separate compute and storage, offering the ability to size a cluster based on your compute needs and scale storage separately. With RA3 instances, data is stored in Redshift managed storage based on the heat of the data. The frequently accessed data blocks are stored locally on the RA3 node, while the colder data is automatically offloaded to S3. The Redshift spectrum is one of the most important features of the Redshift. The Redshift spectrum allows the user to run Redshift SQL queries directly against a vast amount of data stored in Amazon S3 without the need for loading or ETL. The spectrum essentially extends the analytic power of Redshift beyond the data stored on local disk in your data warehouse. And with Redshift Spectrum, you can handle exabyte data. The Spectrum is highly cost-effective. You pay only for the queries you run, and there is no need for upfront cost or commitment. The Redshift Spectrum integrates with AWS Glue, allowing easy discovery and cataloging of data. And finally, I will introduce the Redshift security feature. Like other database services, Redshift provides the encryption for data storage, network security with VPC, and logging and trail functions. And you can control access to Redshift table, database, schemas, per function access control, and per column access control for table views. Next, I'm going to introduce DynamoDB key value type database. The Amazon DynamoDB is a free managed key value database. The DynamoDB is a really popular NoSQL database and widely used for several use cases. The DynamoDB has high performance, it has excellent processing speed, and is used for content management, catalogs, user profiles, and other applications. The DynamoDB is serverless, so you don't need to build, patch, or scale servers, and the disk capacity for data storage automatically increases or decreases. A DynamoDB has excellent scalability. You can execute SQL-like query and operate with external APIs. A DynamoDB has high availability and automatically stores data in at least 3 availability zones. And you can enable global tables to distribute data across multiple regions. The DynamoDB has 2 capacity modes, on-demand and provisioned. As the name implies, in the on-demand mode, users pay for what they use, while the provision mode is useful when capacity is predictable in advance. Now here is the comparison chart of the 2 modes. The on-demand mode is ideal for users who have unpredictable application traffic and don't want to manage capacity planning. And it offers the automatic scaling without capacity planning. But the cost can be unpredictable if the traffic suddenly surges. The provision mode requires users to specify how much read and write capacity they expect to use. This mode can be cost-effective for applications with stable or predictable workloads, but may require manual adjustment to handle unexpected traffic spikes. The DynamoDB streams captures the time-ordered sequences or item-level modification in any DynamoDB table and store this data for 24 hours. The DynamoDB stream captures a record of changes to items, insert, update, and delete. The DynamoDB stream includes the record and shard ID. The use cases of DynamoDB stream includes the replication. You can use the streams to replicate item-level data from one table to another across AWS regions. And analytics, to analyze the changed data and potentially feed it into other systems such as Amazon Redshift or AWS Lambda. The change notifications, used with AWS Lambda to process or act upon the change data. For example, you might send a notification whenever an item is added or updated in your table. You have to enable DynamoDB streams in order to use global tables. The DynamoDB Accelerator, or DAX, is designed to boost the read performance of your DynamoDB tables, offering the microsecond response time for accessing your data. The DAX enables you to achieve faster performance for demanding, read-heavy workload. The DAX improves the DynamoDB read performance by up to 10 times, even at millions of requests per second. The DAX is an in-memory caching service, which means it keeps frequently accessed data in RAM, reducing the need to access the underlying database for read operations. DAX take write-through strategy. When a write occurs, DAX write both to cache and to DynamoDB. For read, the DAX first checks the cache. If it finds the data, it returns it. If not, it fetches the data from DynamoDB and caches it for future requests. This is an example of IAM policy allowing action on a DynamoDB table. And usually actions on DynamoDB tables are executed through API, and you can control access to DynamoDB by IAM. And I will introduce some actions of DynamoDB in terms of the performance. The first here is the difference of query and scans. The query is retrieving the specific item based on the condition, and it typically returns an array of items. The while scan operation is to scan the entire table. It is recommended to opt for query instead of scan in terms of performance, because scanning all the table items can be time-consuming. If you must use scan, it's advisable to leverage filter expression to narrow down the result and make the scan target smaller. It's crucial to note that in DynamoDB, the maximum response size for both query and scan is 1 MB, so if the result exceeds this size, it will be paginated. Next is differences between batches and the transaction. In DynamoDB, the batch method is particularly useful for writing and reading large amounts of data. The batch write item and the batch get item execute parallel processing. The batch processing continues until completion, even if it fails. Any items that fail to be written or read are recorded as unprocessed items. On the other hand, with transaction, the multiple actions are bundled together and processed as a unit. The transaction is all or nothing principle. This means that if any part of the transaction fails, the entire transaction will be rolled back and failed. Since the DynamoDB is a key-value database, the key design is very important in terms of performance, data integrity, and operations. And you can use partition key and sort key for DynamoDB table. The partition key is unique for each partition. You can use the key as primary key. And sort key is used as a composite primary key in conjunction with partition key. And this is a very simple table. The ID as the partition key and the order name as sort key. You can search with partition key or scan all, and you can search with specific key or scan all by composite key. Also, the query search by specifying a range of sort key. And there is another important point about the key design. In DynamoDB tables, the hash value of the partition key determines which partitions are distributed. The partition key should be random value to facilitate distribution. If a regular or sequential value such as date or item number are used as keys, the accesses may be concentrated on specific partitions, resulting in poor performance. When specifying the partition key, suffix the key with the suffix to make it easier to avoid access concentration when hashes are calculated. The image on the left is a sample where the values concentrated by the year, month, and the day are used as partition key. Since the dates are regular value, it's not easier to use them as the partition key as they are. And the right image shows the samples where the random suffix is added to the date. Now I'm going to introduce another important feature of DynamoDB, the secondary index. The DynamoDB has two types of index, the local secondary index, LSI, the global secondary index, GSI. The secondary index allows for more flexible clarifying of your data beyond what's possible using just a table primary key. And this is the comparison chart of LSI versus GSI. And LSI allows for query on both the primary key and alternate the key within the single partition. It's local because it scopes to a particular partition key value. In other words, the partition key remains the same as the base table, but the sort key is different. A GSI allows the querying on the completely different primary key than that of the base table. It's global because it spans across all the partition key values, allowing for queries that are not concentrated to single partition key value. In both LSI and GSI, you can project additional non-key attribute from the base table into the index, allowing you to retrieve items from the index without needing to go back to the base table. The secondary index is very useful in improving the readability. The index may appear to be especially useful to NoSQL databases which have low readability. However, From a performance standpoint, you should not add index in blind. Then I'm going to introduce best practice and anti-pattern of secondary index. Don't add secondary index blindly. Understand your access pattern, weigh the benefits against the cost, and design accordingly. While secondary indexes introduce additional cost, they can be indispensable for optimizing the read-heavy or query-heavy applications. The key is to strike a balance. Design your table and indexes based on your application's unique requirements and access pattern. Ensure you are getting more benefits from the indexes than the cost they introduce. Disadvantage of adding secondary index are that it's gonna worsen performance, storage, and read cost. The creating and maintaining indexes has the performance cost. Every time you write to a table, any associated indexes must have also be updated. So if you have multiple secondary indexes, the write cost will be higher. The secondary indexes consume more storage. For each secondary indexes you create, you are effectively storing another copy of your data. While secondary indexes can speed up query operation that would otherwise require full table scans, they also introduce a read cost. When you read from the secondary index, you are consuming read capacity unit. This is a sample-based table to illustrate LSI and GSI. This table consists of order ID, the order name, the price, the purchase quantity, and the date. Specify the order ID as the partition key and the product name as the sort key. In the LSI, the partition key is left unchanged and only the sort key is changed. In this example, sorting is done by date. And GSE changes both the partition key and the sort key. And next, I'm going to introduce ElastiCache. The ElastiCache is a managed caching service, allows you to deploy, operate, and scale an in-memory cache in the cloud seamlessly. ElastiCache is a managed service which manages the administrative tasks like hardware and software provisioning, setup and configuration, and patching of the software and monitoring. ElastiCache support for popular caching engine, Redis and Memcached, and which I will introduce in the following page. With ElastiCache, you can start with a small cache instance and then scale up to a larger instance or partition your data across multiple cache instances. ElastiCache for Redis supports multiple AZ deployments, which enhances availability by allowing automatic failover in the event of failure. ElastiCache has a cluster mode, which enables high scalability and availability. Use cases of ElastiCache include database caching, session store, real-time analytics, message brokering. It's especially beneficial for the read-heavy or compute-intensive applications. And this is the comparison chart of Redis versus Memcached. As you can see, the Redis support many data types. On the other hand, Memcached support only simple key value pairs. The Redis has many features such as the data persistence, replications, the partitioning, the backup, and so on. On the other hand, Memcached doesn't. In summary, Redis has the many features, but Memcached doesn't. However, Memcached has multi-thread with a simple data type so that Memcached has high performance. And Redis is used for caching, real-time analytics, geospatial data, and more, and Memcached for simple caching. The ElastiCache for Redis offers two modes: the cluster mode disabled, which is a single node setup, and the cluster mode enabled, a multiple node, a sharded setup. The cluster mode enabled allows for horizontal scaling and support partitioning your data across up to 500 shards. In essence, whether you choose cluster mode enable or disable depends on your application's requirement. If you need to handle large amounts of data and require high availability and partition tolerance, the cluster mode enabled might be more suitable. On the other hand, if you have a smaller dataset or rely heavily on operations that need a single node context, like a certain multi-key operation, the cluster mode disabled might be a better choice. This is an example of architecture with ElastiCache. The session data is stored in ElastiCache. The temporarily stored queries to RDS in cache to eliminate duplicate queries, the shorten application response time, and reduce load. The store response from RDS to eliminate the duplicate responses too. And I will introduce ElastiCache failover. For Memcached, in the event of failure, the Memcached automatically replaces the node. The connection from the application to the node is automatically detected by the cluster. For Redis, when a failure occurs on the primary instance, the lead replica is promoted to the primary instance. If the lead replica fails, the primary instance assumes read and write responsibility. And if you need to create a new lead replica, you must add it manually. And next, I'm going to introduce the DocumentDB. Amazon DocumentDB is a free managed document database that is compatible with MongoDB. It's suitable for applications such as web and mobile and IoT that handle large datasets. The main features of DocumentDB are as follows here. By separating and read and write workload, it enhances scalability and performance. Additionally, creating extra replicas further boosts read scalability. The data is replicated and stored on AWS storage, ensuring the data durability and availability. It also supports multi-AZ deployments, allowing for automatic recovery from failures. Existing MongoDB application can be migrated to DocumentDB without any modification. Moreover, interaction with the database can be conducted using the MongoDB API. Leveraging the AWS security features such as network isolation, encryption, and access management ensures the safety of the data. MongoDB is a high-performance, scalable, document-oriented database and developed and supported by the MongoDB Incorporation. It utilizes a JSON-like document, which is called BSON, to flexibly represent complex hierarchical data structures. This allows the bundling of multiple related data within a single record, and simplifying the data handling. It supports horizontal scaling through sharding ensuring the system performance is maintained in response to increase in the data volume or traffic. The MongoDB boasts rich query capabilities, offering the search, sort, and aggregation function comparable to SQL database. It also supports geospatial queries. With the replica set mechanism, it guarantees automatic failover and redundancy of data. This ensures the overall functionality of the database is maintained even if some servers fail. The document-oriented database offers flexibility and scalability, and their use cases are diverse. Due to the ability to store data in various formats, it's well suited for managing different types of content. With fast read and write capability and horizontal scaling, it is more suitable for processing a large amount of data in real time. The document database are schemaless, allowing for flexibility regardless of the data structure. In mobile and web applications, data structure frequently change. The catalog for products or services which have various attributes, which are aptly stored within the single document. Compared to RDB system, the document database are schemaless, have a flexible data structure, and are capable of horizontal scaling. The relational database have a strict schema, normalize the data structure, and are suitable for complex queries and transactions. Compared to key-value database, the document database processes a rich data structure and can handle complex queries. They represent the single entity as a single document, allowing for the storage of the related data together. And here is the sample data and queries for DocumentDB. The database contains the book title, authors, and so on. And it contains both strings and numbers. Unlike relational database, in MongoDB, you do not have to define the data schema in advance. You can also include multiple attributes in the single item. In this way, you can create a flexible database. And these are the sample queries, the find, update, and remove. And you can specify items in the database to perform flexible queries. And next, I'm going to introduce the Amazon Neptune. Amazon Neptune is a free managed graph database service. The Neptune is fast and reliable, allowing for intuitive handling of complex graph queries. Unlike RDB or NoSQL database, the graph database model data as a collection of node and edge. This allows for the representation of data with deep relationship and intricate pattern, such as network, social network, hierarchies, and complex interconnections. Neptune can be used for purposes such as analyzing the relationship in social networking site, the product recommendation system, the fraud detection, and managing the network topology. The Neptune offers the graph processing engine with swift query response time and high throughput. It provides the automatic backup, data restore, and failover, enhancing the data durability and reliability. It ensures data security by offering the data encryption, network isolation, and access control. Supporting the Open Graph Query language, Gremlin, and Sparkle, it allows for versatile handling of the various types of graph data. Now here is a sample database of the Neptune. Now here, for the nodes named Alice, Bob, and Charlie, the relationship between each node is represented by an edge. And this query sample of the Gremlin and Sparkle, the syntax for graph-oriented DB. The syntax is different, but what they can do is almost identical. And next I'm going to introduce the Amazon Timestream. The Amazon Timestream is the managed database for time series data. The time series data refers to the series of data points that change over time. It can accommodate the various use cases that handle the time series data, such as collecting the telemetry data from IoT devices, analyzing the financial transaction, and monitoring IT operation metrics. The time stream automatically scales up and down, adapting to the changes in data over time. It can collect, store, and process vast amounts of time series data in real time. It has a feature to manage the data lifecycle, where frequently accessed recent data is stored in memory, and all the data is automatically moved to low-cost disk storage. This minimizes the storage cost. It supports querying time series data using SQL. It offers numerous built-in functions for data analysis, such as moving averages and rate of change. It seamlessly integrates with other AWS services. For instance, it can directly collect data from Amazon Kinesis or AWS IoT Core. For database visualization, Amazon QuickSight or Grafana can be utilized. The same NoSQL database, the DynamoDB, can process the time series data by having keys and attributes such as timestamp, but Timestream includes more optimized features. The Timestream is a relatively recently released service with general availability in 2020. In other words, before Timestream was released, other databases such as DynamoDB were used to process time series data. Here is a table comparing the DynamoDB and the Timestream. The comparison is based on the data type, the performance, storage, and the cost, the query, the language, and the integration. The Timestream is specialized for Timestream data, making it great for things like telemetry data, whereas DynamoDB's versatile design makes it suitable for a wide range of applications that require consistent single-digit millisecond latency. The time series data refers to the sequence of data points arranged as a function of time. Typically, it's recorded at regular intervals, every minute, every hour, or every day. Because of its real-time and scalable nature, the time stream is used for collecting and processing time series data from IoT devices connected to AWS IoT, or retrieving and processing data in real time that has been collected via API gateway or AppSync. On the other hand, if you don't need real-time processing and scalability, you may better to use Amazon Athena with S3. And these are use cases for Amazon Timestream. The Timestream has a function designed for time series data, enabling processing just by calling the functions. And since time series data is acquired regularly, it allows for the time-based aggregation the time series analysis, and calculations such as anomaly detection and the moving averages. And next, I'm going to introduce the processing domain. In this chapter, I'm going to introduce ETL processing and some processing-related services. First, I'm going to introduce ETL processing. The ETL is traditionally used with mainly batch processing system where the transformation happens before loading the data. And due to the advances in powerful cloud-based data warehouses like Snowflake, Google Cloud BigQuery, and Amazon Redshift, the ELT has become increasingly. This is because these platforms can manage the heavy workload of transforming data after it's loaded. Each phases of ETL process can have the potential bottlenecks, and these are elements that might cause the bottlenecks for each phases. In extract process, the slow performance of the original data source, the high-frequency streaming data, extracting data from multiple sources simultaneously, and API limitations are cause of bottlenecks. In transform process, the complex computations such as advanced aggregations, joins, calculation, data cleansing large amounts of data, and data integration such as merging or looking up can become complex and be a source of bottlenecks. And in load process, the performance of the destination database or data warehouse, the loading large dataset at once, the overhead transaction can become the bottlenecks. In addition to these factors, network bandwidth, communication latency, performance and the configuration of ETL tools, and the availability of the resources can also be potential sources of bottlenecks in the overall ETL process. Taking these into account, we need to design the ETL pipeline. AWS offers a range of tools and services for both batch and streaming ETL needs. For batch ETL, AWS includes services such as AWS Glue and EMR. And on the other hand, for streaming ETL, AWS provides services like Kinesis and Lambda. These services cater to various workloads and use cases depending on the data integration and analysis requirements. And now I'm going to introduce the AWS processing related services. The first one is AWS Glue. The AWS Glue is a free managed ETL service which extracts data from external data source, ingest it, and transform it into the format suitable for analysis. It supports S3, RDS, DynamoDB, the Kinesis data streams, and the DocumentDB as the data sources, and S3, RDS, and the DocumentDB as data target. The Glue crawler interprets the data source and inputs the table definition into data catalog. If S3 is the data source, you can use the incremental crawl. This will crawl only data that have been added since the last crawler runs, and reducing the read time. Glue data catalog source definition will map to the target and automatically generate Python code. And this allows for the definition of ETL jobs. This is an overview of AWS Glue, and I'm going to introduce each component from next page. The Glue crawlers are used to automatically infer the schema and extract metadata from your data source, and then create the table definition in the data catalog. And here is the sample, the breaking down of the types of metadata. The metadata includes the table information, and which includes the general details about the table itself. And the table property are key value pair that provide additional detail or characteristic about the table. These properties could be manually added or automatically populated by the crawler. And the table schema represents the structure of the table, detailing each column's name, data type, and any other relevant attribute. The Glue supports versioning of the Glue catalog. You can manage the versioning in the Glue catalog, and it's possible to obtain the differences based on the versions. Then you can connect S3, DynamoDB, and JDBC. And for S3 and DynamoDB, you can manage the load with IAM. And the database on as a cloud service or on-premise, you use the JDBC. The AWS Glue job can be defined using Apache Spark or Python shell for ETL process. You can specify the DPU, the data processing unit. The one DPU is equal to 4 vCPU and 16 GB memory. And the Glue offers the bookmarking feature to create a checkpoint within a job. This bookmark feature can be enabled, disabled, or paused. It ensures that only the newly added data is processed in the reruns, and skipping the data already processed in previous runs. The data frame is a concept that borrows from the Spark and represents the distributed collection of data organized into named columns. The data frames are immutable and can be transformed into new data frames using operations like filter, aggregate. The dynamic frame is, on the other hand, is specific to AWS Glue and is designed to provide flexibility for ETL operation, especially when the schema of data is not known in advance or is dynamic. The dynamic frames are more tolerant to schema variations and offer transformation specific to Glue, and they can be easily converted to and from to data frame when needed. When it comes to computing engine, for small-scale data, you can use Lambda, and for medium-scale data, the Glue with Python shell, and for large-scale data, ETL Glue with Spark is available. The AWS Glue jobs can be initiated in a couple of ways, catering to different use cases and requirements. Jobs can be scheduled using Cron, allowing you to run ETL tasks at a specific interval or times. This is useful for regular data processing tasks such as daily or hourly aggregations. The Glue jobs can also be triggered based on a specific event. This offers the flexibility in responding to the changes or specific condition in the data processing pipeline. The Glue employs a DAG for its job workflow. The DAG ensures that the tasks in the ETL process are executed in the particular order without cycle, making the entire process more efficient and predictable. Each task in the DAG depends on the completion of its procedure, ensuring the data flows smoothly through the entire transformation and loading process. And this is the image of Glue Studio in which DAG is described. From here, I will introduce some of the new features that have been released relatively recently. Some of the features are in preview at the time this course was published. The first, AWS Glue Data Brew, is a visual data preparation tool that allows users to clean and normalize data without writing code. With over 250 built-in transformations, you can easily explore, combine, and reshape data for further analysis and machine learning. It supports various data sources, including the data lakes, data warehouse, and the database. The Data Brew provides an interactive interface where users can visualize data patterns, outliner, and other statistics, making the data preparation phase more intuitive and efficient. AWS Data Quality provides the data profiling capability to help users understand and improve the equality of the data. And you can set up the quality rules, continuously monitor the quality of the data, and it can be alerted on the data inconsistencies or anomaly. And this ensures the data being used for analytics and machine learning is accurate, complete, and meets predefined quality standard. The Glue data quality integrates seamlessly with other AWS Glue features, offering a comprehensive solution for data preparation and quality monitoring. And lastly, AWS Glue for Lay helps data engineers and ETL developers scale their Python job. Lay is an open-source distributed computing system. It was deployed to make it easier to scale and distribute Python applications, particularly for machine learning and API use cases. The Lay provides a unified API for tasks, the parallelism, and the actor-based distributed computing. This means you can develop your application on your local machine and then scale it out across the cluster without significant changes. The Lay can dynamically execute tasks with complex interdependencies, which is essential for many machine learning algorithms. And Lay has native support for integration with popular machine learning frameworks like TensorFlow, PyTorch, and Scikit-learn, and this makes it easier for developers to scale machine learning training and the interface workload. Over time, the community has developed several higher-level libraries on top of Lay to support specific patterns like Lib for reinforcement learning, Lay tunes for hyperparameter tuning, and Lay serve for scalable model serving. And Lay supports both batch and stream processing and can be used for a wide range of applications, from ETL jobs to web server to deep learning training. Next up is AWS Lambda. AWS Lambda is a function as a service that allows for the construction of actions and conditional branching based on the event-driven triggers while integrating with various AWS resources. It is serverless and free managed, and you can only build during the function execution, enabling high availability and cost-optimal function execution. The Lambda supports programming languages such as Java, Node.js, C#, Python, Go, PowerShell, and Ruby. Even if a language is not natively supported, it can be defined as the custom runtime. While Lambda works with various AWS services, it's necessary to grant IAM permissions to execute the Lambda functions. Lambda supports a wide range of event-driven use cases. For example, execute function triggered by HTTP request through the integration of API Gateway and Lambda, add metadata to data upon its upload to S3 as a trigger, and the daily execution of start and stop actions on EC2. The typical architecture is as follows. An application on EC2 sends a write request to DynamoDB, and use the SQS. The producer and the consumers are separated asynchronously. And if the number of failed SQS processes or the queue wait count exceeds a certain threshold, the Lambda's the conditional branching issues an alert. And this is the Lambda function that adds in an item to DynamoDB when a certain number of messages accumulates in SQS queue. The term bottle3 at the top is an invocation of the AWS SDK for Python. And for your reference, the bottle is named after the Amazon River dolphin. The Lambda handler is also referred to as the event handler function, serving as the function that processes event in Lambda. And it retrieves the endpoint of SQS queue and obtains the attributes of the SQS queue. The approximately number of messages represents the number of messages queued up. And there is an if statement that adds an item to a DynamoDB when the number of messages exceeds the 10. And next, I introduce the Lambda layers. The Lambda layers are features that packages library and dependency so that they can be used and shared across multiple Lambda functions. In the past, without the Lambda layer, it was necessary to upload library and dependency for each Lambda function by a zip file, but now it's common practice to use Lambda layer. In Lambda, you can set versions and alias. The version in Lambda allows for the coexistence of old and new versions of code when it's updated. When you update the code, a new version is created. And alias, on the other hand, enable you to create a separate environment distinct from the production environment. For instance, you can create multiple alias, such as for production, deployment, and staging environment. The ARN will include both the version and alias. However, the ARN for the initial version does not contain the version number. In Lambda, the billing is based on the number of function execution, but Lambda provides the timeout setting to prevent the function from running indefinitely. By default, the timeout is set to 3 seconds, and the maximum execution time per request is 900 seconds. It is equal to 15 minutes. And this makes Lambda useful for relatively short batch job, but it's not suitable for processes that exceed the 15 minutes. The other quota related to Lambda include a maximum of the 512 megabytes data storage in the per temporary directory. The total size for function and layer is 75 gigabytes, although this can be increased upon request. The concurrency limit is 1,000 simultaneous execution per region. but this too can be increased upon request. The memory allocation starts at 128 MB by default and can go up to over 10,000 MB. A maximum of 5 layers can be assigned to a function. The best practice and anti-pattern, it recommends to use environment variable. For common module and library, use lambda layers, and avoid recursive code. In other words, avoid triggering the same function from within itself. And next, I'm going to introduce the Amazon EMR and Hadoop ecosystem. The Amazon EMR is a large-scale distributed processing platform that uses the Apache Spark, Apache Hive, and Presto. EMR handles the petabytes of data analysis, and perform machine learning. As the name Elastic MapReduce suggests, it can be connected to a variety of data sources for scalable processing. The computing and storage can be scaled independently for cost-optimal operation. The EMR automatically scales clusters and automatically shuts them down when processing is complete. In addition to S3, HDFS is provided in the cluster for data persistence and works with big data such as S3, Kinesis, and DynamoDB. In order to understand Amazon EMR, you need to understand the Hadoop ecosystem. On the next page, I will introduce the Hadoop ecosystem. The Apache Hadoop is comprised of the core components that work together to handle and analyze a large dataset. And it utilizes the Hadoop Distributed File System, HDFS, which is the primary storage system designed to store massive files across the multiple machines. The MapReduce is employed as the programming model essential for processing and generating a vast dataset through parallel operations. The Hadoop integrates the Yarn, yet another resource negotiator that acts as a resource management layer, ensuring that the system's various components can access the resources they need efficiently. And Hadoop Common provides the shared utilities and library, serving as the glue for the other Hadoop module, ensuring the seamless integration and functionality. And for data storage need, Hadoop can interact with HBase, a non-relational and distributed database running a stop HDFS, designed for the quick read and write access to large volumes of data. And when it comes to data processing analysis, the various tools and frameworks are to be used simultaneously. The Hive offers a data warehousing solution along with SQL-like query language, aiding in the data summarization, the querying, and in-depth analysis. The Apache Pig is a high-level scripting language that facilitates the data analysis and simplifies the creation of MapReduce program used in conjunction with Hadoop. Apache Spark, an open-source distributed computing system, offers a rapid and robust framework for big data processing, providing an efficient alternative for handling large-scale data analysis tasks. In typical Hadoop configuration, the Hadoop Distributed File System (HDFS) is crucial as it establishes the distributed file system spread across the multiple servers. Within these clusters, Yarn plays a pivotal role by managing vital resources, including the CPU and memory, and this management ensures that the cluster operates efficiently and effectively for various tasks. The MapReduce framework is designed to conduct parallel and distribute batch processing, operating seamlessly on top of Yarn, which enhances the ability of the system to handle and process large datasets in parallel and distributed manner. In this ecosystem, HBase and HDFS work together to provide a comprehensive data handling solution. The HBase is adept at performing read and write operations on large amounts of small data, providing flexibility and efficiency for handling diverse data types and volumes. On the other hand, while HDFS excels at the reading and write large files with high throughput, it is not inherently designed for operation typical of relational databases. And this limitation is due to its nature as a file system, not a database management system. However, when HBase and HDFS are used together, they complement each other, with HBase filling the gaps and providing a functionality that are not natively available in HDFS. The image on the left illustrates the structure of HBase. The master node is responsible for the management and the control of entire cluster, and the zookeeper tracks the state of the cluster and plays roles such as detecting the master node failure and electing leaders. The client node serves as an interface for executing queries to HBase and perform the data success operation. Additionally, slave node, which handles the storage and manipulates of the actual data, operates under instruction of the master node. On the right side, we have the configuration of HDFS. Since HDFS possesses the characteristic of the distributed file system, the specific elements play a central role. The master node acts as a name node, the management the metadata for the entire cluster, as well as the file system namespace. The client node functions as an interface for executing file operations like reading and writing on HDFS. And the slave nodes are responsibility for storing and replicating actual data, operating under the instruction of the master node. The MapReduce is a programming model and corresponding the architecture designed for processing large amounts of data in parallel. It comprises two main steps, map and reduce. In the map step, the model takes input data and transforms it into the smaller set of data, especially into the pairs of key and values. During the reduce step, the model takes the output from the map step, aggregates the data for each key, and generates the new pairs of key and values. And here is a simple sample data flow of MapReduce process. First, counts the words at the initial state. Read each row and outputs the word as the key and the number 1 as the value in map step. Group same word in the shuffling phase, but it is actually implicit. And finally, aggregates the value of data with the same key in reduce step. This is a very simple sample, but the MapReduce in practice can be a powerful tool that allows the same process to be applied the scalability to terabytes and petabytes of data, AWS has developed a distributed node to run MapReduce using the standard SQL, and creating an environment that makes large data more accessible. AWS offers a wide range of database and analytics tools, and considering the following distinction for different use cases would be beneficial. If there are data sources other than RDS and S3, and you want to bypass Athena's concurrent query execution limit, then consider using Presto on EMR instead of Athena. And for those who want to utilize the spot instances for ETL process, improve the specification of a single node, or use Spark for ETL process using Spark on EMR instead of AWS Glue. If there's a need for flexibility in customizing a streaming application, using Spark on EMR instead of Kinesis data analytics. And for those who prefer using an existing HBase, it would be better to use EMR instead of DynamoDB. And again back to EMR explanation. The EMR clusters are composed of the following primary node type. The master node manages and controls the cluster. It runs components like Hadoop, Job Tracker, and Spark's Spark context. And the core node provides the HDFS storage and executes the MapReduce tasks. A portion of the data is stored on this node. And the task node exists solely to execute MapReduce tasks and doesn't have HDFS storage. It is added to increases the clustered processing capacity. Amazon introduced the managed scaling in 2020, providing the advanced method for automatically adjusting the size of your cluster based on your workloads. This feature is compatible with both instance group and instance fleet. Impressively, it can scale a mix of spot instances, on-demand instances, and instance with the saving prompt, they're all within the same cluster. The managed scaling is available for a range of workloads, including the Spark, Hive, and Yarn. When it comes to the scale-up strategy, the EMR first increases the core node. Once the core nodes have been maximized, it then adds the task node, all the way up to the predetermined maximum limit. On the other hand, the scale-down strategy operates in reverse. The EMR starts by removing the task node. Once those are minimized, it then deducts from the core nodes, ensuring it doesn't drop below the set minimum constraint. A notable feature here is the prioritization. When scaling down, the spot nodes are always the first to be removed, followed by the on-demand instances. There are several storage options in EMR. Firstly, HDFS, the Hadoop distributed file system, which spreads data across cluster instances for redundancy. HDFS breaks file into blocks, typically of size 128 MB by default. However, a crucial thing to remember about HDFS is its ephemeral nature. If you terminate the cluster, the data stored in HDFS is lost. This transient quality makes HDFS suitable for caching intermediate results and handling the workloads that improve significant random I/O. One of the advantages of Hadoop design is its preference to process data where it resides on HDFS minimizing the data transfer times. To bridge the gap between ephemeral and persistent storage, EMR introduced the EMRFS, which allows you to access S3 as if it were HDFS. With EMRFS, even if cluster is terminated, your data remains persistent in S3. And plus, for those concerned about consistency in S3, there is the EMRFS Consistent View feature, which uses DynamoDB to maintain data consistency. In addition, EMR also supports local file systems, primarily suited for temporary data needs. And for those who prefer Elastic Block Store or EBS with their EMR clusters, especially with EBS-only instances, types like M4 and C4, there is EBS for HDFS options. And just remember, similar to HDFS, EBS volumes are also deleted upon cluster terminations. And in the last EMR serverless, unveiled at the AWS re:Event 2022, offers a simplified way to run big data tasks. The users choose an EMR release and runtime, with choice like the Spark, Hive, and Presto. After this, you can easily submit queries or script using job run request. The one of the key features is that EMR tasks care of managing the needed resources, while users can set default worker sizes and certain capacities. The EMR calculates the resources your job needs and schedules the workers accordingly. And all of this happens within one region, but can spread across different availability zones. The main benefit is that it reduces the management overhead of guessing how many worker nodes your task will need EMR. And the EMR serverless provides these workers automatically based on the job need. Next, I'm going to introduce step functions. AWS Step Function is a state machine service designed for constructing, managing, and automating the execution process of workflow for distributed applications and microservices. It allows for the visualization of each service as a component within the workflow format. By combining it with serverless and scalable AWS service, you can build flexible workflows. And step function makes the microservice loosely coupled, which enable independent scaling and modifications. While SQS is useful for a serial workflow in the process of decoupling, the step function can be utilized for a parallel workflow as well. And this is the sample state machine created with step function. And it's possible to construct a complex workflow, including the parallel processing through conditional branching. The activity worker is a component that interprets and executes a specific task. It is a piece of code or application that directly interacts with the task represented in the state machine. An activity state is the state type used within the state machine to delegate the specific task to an activity worker. It's a way to represent the unit of work to be performed. These are types of activity state. The wait represents the waiting period. In this state, the process waits until the specified time or date is reached. It is often used when there is a need to synchronize the timing within the application. The choice state is for conditional branching and is equivalent to the case statement in programming language. It directs the workflow to different branches based on the specified conditions. And the fail state is used to express the name and the reason when there's an error during the execution of the state machine. It effectively stops the execution of the state machine and returns an error. The parallel state allows for the concurrent execution of multiple branches of your workflow. And once all branches have completed their execution, the workflow will proceed to final state. The map state is designed for the parallel processing of dynamic arrays. It contains an array called the item path, and the iterative processing is performed for each variable within this array. The map state allows you to process an array of items in parallel by invoking the specified iterator for each item in the array. Each of these states provide a unique functionality that can be utilized to design and control complex workflow effectively within the step function. In step function, not only can you define the tasks and pass through a graphical workflow, but you can also use JSON-based language called ASL, Amazon State Language. Here we have a sample of the ASL that was featured in the technical vlog. Within ASL, you can specify the details such as the name of state, the parameters, the retry configuration, the result path, and more with precision. The step function offers two types of the workflow, the standard and the express workflow. And here's a brief overview. And there is the differences between the workflow in terms of start rate, cost, level of detail required in logs and history. But the key differences is the execution duration. The standard workflow offers up to 1 year. On the other hand, express workflow offers up to 5 minutes. In the context of application integration, SQS and the step function are often compared. The SQS is a messaging queue service used to decouple a scale application, and the step function is a service to coordinate multiple AWS services into workflow. And here is the comparison chart of both. SQS integrates application in a linear fashion, whereas step function integrates application by forming complex workflows such as parallel processing, iterative processing. In terms of scalability and cost, SQS would be less expensive to integrate a large number of applications. I will present the sample on the next page. This is the sentence of AWS certification exam. The actual question text is a bit longer. A mobile application company has developed an application that extracts the metadata from user uploaded photos and creates a photo catalog. The application is hosted on the AWS, and an AWS Lambda function extracts the metadata from the photos to create a catalog. The metadata is categorized by date, location, and etc. And the extracted results are output to Amazon ElastiCache for Redis cluster. The answer to this question is to use SQS to create another Lambda function that sends photos to Amazon SQS queue, extends the batch size of the Lambda function that performs the extraction process, and configure it into the subscribe to and run from SQS queue. The scenario for this question is illustrated in this way. The multiple users are uploaded photos which are processed in parallel, but one by one in linear fashion. The step functions are built based on the number of state transitions in the workflow. In the scenario in this question, the metadata extraction process is executed for each number of photos, which is not the cost-optimal method in the situation where the number of users is increasing. On the other hand, SQS is cost-optimal even for large number of requests, and is useful for repetitive simple processing, such as in this question. In this way, the differences between SQS and the step function is frequently shown up in the examinations. Next, I'm going to introduce API Gateway. Amazon API Gateway is an interface used for the web application and a free managed service that allows you to easily create, protect, and publish and monitor API. It supports HTTP API, RESTful API, and WebSockets. It supports traffic management, CORS, and monitoring. For cost of API Gateway, it's charged only for the number of API calls received and the amount of data transferred, but it's not charged for the data transfer for private APIs. API is allowed only for IAM user authorized. By including the JSON Web Token obtained by the Amazon Cognite, the user pool in the authentication header, the API can be controlled so that the only authenticated user can execute the API. The performance of API Gateway can be improved by enabling the caching. However, it will be charged based on the cache capacity. There are three types of endpoint: edge-optimized, and region, and private. The edge-optimized API endpoint is useful by global edge location. The region API endpoint is useful when users are concentrated in the particular region. And the private API endpoint is useful when used from the specific VPC inside. In order to help you grasp the role of API Gateway, I will explain a serverless architecture using API Gateway, Lambda, and DynamoDB with a specific example. Building an online book selling application, through this application, users can add books and retrieve information on books existing in the database. First, the client application inputs data for a new book, which includes the title, author, genre, and price. The application converts this data into JSON format and sends it as a POST request to API Gateway. And this request includes an endpoint, header, and JSON data in the body. An API Gateway receives this request and routes it into the appropriate Lambda function. In this case, it routes the request to the Lambda function designed for the adding books. And the Lambda function passes the JSON data from the request and creates a new record for books in DynamoDB. And next is, on the other hand, the request to retrieve information about the book. The users retrieve information about the specific book through the application, entering the book's ID. The application sends this book ID to the API Gateway as a GET request, which includes the endpoint URL. Upon receiving the request, API Gateway routes it to the appropriate Lambda function as per the configuration. In this instance, the request is routed to the Lambda function dedicated to the retrieving book information. And the Lambda function passes book ID from the request parameter, uses this ID to fetch the corresponding book record from the DynamoDB table. And finally, the retrieved data is converted into JSON format and returned to the user via the API gateway. For adding books, prepare for a JSON file like this on the client application side. The book information includes an ID, which is a primary key, and attributes like title, author, genre, and price. Then there is an empty table in DynamoDB. The post request like this is sent from the client, and the API gateway receives it. The part with HTTPS representing the endpoint URL of the API gateway. The JSON object following the -d option is the request body. And once this request is sent and the writer request sent to the DynamoDB from Lambda function, the data is written into the DynamoDB. And the next GET request to retrieve book information is sent. With the books /get/123, it means retrieving data with the ID of 123 from a DynamoDB table named books. Once DynamoDB receives this request, it sends a response back to the client application. And I will explain the security feature of API gateway. It is common practice to include the security information in requests to APIs, especially API token for authentication. And this allows the server side to associate each request with the appropriate user or application. And here is the example of an HTTP request using an API token. The part under authorization is an example of API token. The actual API token would be inserted where it said your API token. The API gateway is also the excellent scalable. The API gateway also has the excellent scalable features. When a large number of requests are sent from the client, normally a 429 error is returned, but the API gateway automatically scales to handle the load. The API gateway has maximum processing count called throttling. By default, it can handle 10,000 request rate per second and a burst of 15,000 requests. And moreover, it is also possible to increase this throttle count. And therefore, API gateway can be called a highly scalable gateway service. Next, I'm going to introduce AppSync. AWS AppSync is a free managed GraphQL service. It certainly manages access. Next, I'm going to introduce AppSync. AWS AppSync is free managed GraphQL service. It centrally manages access, manipulation, and real-time update to data from applications. Replacing REST, the GraphQL provides a flexible query language that allows the client to fetch only the data they need. It offers the managed services for the entire operation of GraphQL API, including the definition of GraphQL schema, implementation of logic, and the connection of data sources. Using the GraphQL subscription operation, the clients are automatically updated when data is changed. And AppSync supports offline operations, which allows users to use application even when offline. When back online, it automatically synchronizes the data. The AppSync seamlessly integrates with other AWS services and can be used as a data source. The AppSync supports various authentication mechanisms, including the IAM, Cognite, OIDC, API keys, and custom automation logic using the Lambda. The GraphQL is a data query and the manipulation language developed by Facebook. The GraphQL allows clients to define the data structure and fetch the data. Unlike the REST API, the GraphQL enables clients to specify in detail which data they should receive from the server, and leading to the reduction in data transfer and improved efficiency. With GraphQL, clients can specify the data they need, and only the targeted data is retrieved from the server. By narrowing down to only the necessary data, the data volume and the cost can be optimized. With one GraphQL request, the data can be fetched from multiple data sources, and this reduces the number of network requests. The schema of GraphQL API is predefined, and the only queries that comply with the schema can be executed. GraphQL supports real-time data updates through subscriptions. This is the comparison chart of GraphQL versus REST API. For example, in the fetching data, the query of GraphQL is equivalent to the get of REST API. The GraphQL offers a more flexible and often more efficient way of interacting with the data compared to REST API, especially when dealing with complex systems or when the exact shape of the response needs to be tailored to various clients. On the other hand, REST remains a simple, straightforward, and widely understood option for building APIs. I'm going to introduce AppSync and GraphQL. Here, using the real-time live score display, which assume a game commentary or sports commentary as a sample. I will explain the processing of the AppSync. First, define a mutation to accept the source update from the media and a subscription to receive update in real time. The client sends a query using GraphQL subscription to subscribe to score update. Through AWS AppSync's GraphQL resolver, the data is sent to DynamoDB. The game scores are written into DynamoDB table. And here is a sample mutation that accepts the score updates from the media and a subscription that receives the update in real time. The schema uses the mutation called the updated score to update the score and the subscription called the score updated to subscribe the score updated in real time. The mutation here means the modifying the data includes the create, update, and delete operation. It is equivalent to the post, put, and delete method of the RESTful API. The next is an example of GraphQL subscription query that the client sends to subscribe to score update. This query instructs the server to receive the updated game ID and score when the score of game ID with 1 is updated. An AppSync can be used to send data to DynamoDB by a GraphQL resolver. For example, to use an update score mutation to write the data to DynamoDB, configure the resolver in this way. In this resolver, when the update score mutation is called, it will create the new entry or update the existing entry in DynamoDB table called the game table. The game ID of the item is taken from the mutation argument, and so is the score. And this setup allows for the operation that receives the data from multiple data sources and stores the data in DynamoDB. This code uses AppSync is VTL, Velocity Template Language, but the same result can be obtained using Lambda. In that case, implements the process of writing DynamoDB within the Lambda function. Next, I'm going to introduce the analysis and the visualization domain. In this chapter, I'm going to introduce the analysis tools such as Athena, OpenSearch, and the AI and machine learning service. As for EMR, Redshift, and Kinesis, I've already introduced in the previous chapter, and I'm going to introduce visualization tools. These are analytical tools offered by AWS, and for interactive analysis tools like Redshift and the Redshift Spectrum, the Athena and the OpenSearch service are available. By using these tools, you can obtain query results immediately. For analyzing the streaming data, the KDA is employed. And in addition, the EMR supports the Apache Spark streaming, enabling the real-time analytics. And for big data analysis, you can use Redshift and EMR. And Redshift is employed for SQL analysis on petabyte-scale data, and EMR provides the framework suitable for distributed parallel process. And for machine learning, the SageMaker is utilized. Firstly, I will explain the Amazon Athena. The Amazon Athena is a serverless interactive query service that enables users to analyze data directly in Amazon S3 using the standard SQL. The Amazon Athena has no infrastructure to set up or manage. You can start querying data instantly. You only pay for the queries you run. The Athena is optimized for the fast performance with S3. It uses the Presto, a distributed SQL engine, with support for data formats like Packet and ORC, which can lead to faster query performance and reduce the cost. You can use standard SQL to analyze any data format that's supported by Apache Hive, and this includes the formats like Packet, CSV, JSON, ORC, Aurora, and more. And with Glue's data catalog, allowing you to use Glue to automatically discover and catalog metadata, and which makes it easier to manage table and database. The Athena employs the schema-on-read approach, meaning the schema is applied at the time of the query, allowing you to store data in its raw form. The data doesn't need to be loaded into Athena, as it queries data directly on Amazon S3, and this is great for ad hoc analysis and reduces the time from the data acquisition to insight. Athena is a tool for analyzing data in S3 using standard SQL. The S3 is an object storage without a folder structure, and the searchability is poor for use cases that store large amounts of data, and therefore analysis by SQL is very useful. This is a sample CSV file of cost and usage report. The cost and usage report are not meant to be viewed by the human eye, as they contain detailed information. They are used for cost analysis in relatively large organizations with many departments and projects. These reports are stored in S3 and analyzed by Athena, or by S3 Select to extract only the necessary portion. Now here is a sample table definition of a constant usage report in Athena. You can also specify the specific object in S3 select and extract data with a similar query. Now I will explain the differences between Athena and S3 select later. And here are the differences between Athena and S3 select. The both services execute queries on data stored in S3, but there are some differences. Basically, Athena is more sophisticated and can execute more flexible query. Therefore, it is usually used as an analytical tool. S3 select, on the other hand, is used to extract data from a specific object. Before you can query your data in Athena, you need to create a database and tables. And there are two ways to create the table, by creating a DDL from the Athena console or by using the Glue data catalog. When you use the DDL in Athena, you are manually defining the schema for your table, pointing it to the location of your data, and specifying the data format. The query shown below is a simple DDL to create a table from the S3 bucket. The Glue data catalog is an integrated and centralized metadata repository that is natively integrated with Athena. It allows for automated schema discovery, data cataloging, and schema versioning. If you want to execute query to database services, the federated query will be helpful. The Athena's federated query features allows you to run SQL query across multiple data sources directly within your Athena console. Initially, Athena was used to query database stored in S3, but with federated query, you can now extend this capability to query across relational, non-relational, object, and custom data sources. Supported resources include the relational database such as Amazon RDS for MySQL, Amazon RDS for PostgreSQL, and so on. The Amazon Redshift, AWS service log like CloudWatch logs, and others. This is an actual image of the Athena console. Choose a data source and you can fetch data from the services shown here. The cost of Athena is based on the amount of data scanned. For example, in Tokyo region, the rate is $5 per terabyte. There are several ways to reduce these costs. Compressing the data using format like gzip, converting to the columnar format by scanning only the columns specified in the query. You can reduce both the amount of data scanned and the cost. Partition the data, organize and store data in segmented section, and filter using the where clause. For example, if you store log data in S3 bucket by date, you can create an external table partitioned by date. Next, I'm going to introduce OpenSearch service. The Amazon OpenSearch service, formerly known as the Amazon Elasticsearch service, is a managed service provides that makes it easy to deploy, operate, and scale OpenSearch and Elasticsearch clusters in the AWS cloud. OpenSearch is a community-driven, open-source search and analytics suite. The OpenSearch takes away the operational complexity, handling the tasks such as the backups, the patching, and the monitoring, so you can focus on the application. It easily scales your cluster up and down as needed using the single API call or a few clicks in the AWS Management Console. It provides the capability for full-text search, real-time application monitoring, logging analytics, and clickstream analytics. It integrates with Kibana, an open-source data visualization tool specifically designed to work with Elasticsearch and OpenSearch data. And with features like ultra-warm storage, you can both optimize cost and maintain high performance. And the clusters can be set up across the multiple AWS availability zones, providing higher fault tolerance. And this is an example architecture of the OpenSearch service. A document is the smallest unit of the data in OpenSearch. It is the same as a record in relational database. A document is usually formatted in JSON and contains information about a specific entity or object. An index in OpenSearch is the collection of documents. It is comparable to a table in relational database, where each document can be compared to row in that table. An index is where the data is stored and searched upon. An index is also made up of one or more shards. A shard is essentially a self-contained index. Each shard contains a subset of the data of an index and functions independently. There are two types of shard: a primary shard, which holds the original data, and a replica shard, which contains copies of the primary shard's data for redundancy and load balancing. And each document has document ID, and the ID is unique. During the sharding, a hash value calculated from the ID of the document is used. Data nodes are OpenSearch nodes that hold the data and handle the data-related OpenSearch, such as CRUD, create, read, update, delete, search, and aggregations. And each data node contains several shards, both primary and replica. And the master node or administrator node is responsibility for the cluster-wide management and the configurable tasks, such as creating or deleting indices, keeping tracks of which nodes are part of the cluster, and deciding which shards to allocate to which node. It does not hold data or handle data-related queries. And when determining how many number of nodes, you need to take data volume, redundancy, the query load, and the read load into consideration. And next I'm going to introduce the storage tier of OpenSearch. The Ultra one is a storage tier feature. Its primary purpose is to offer a cost-effective way to store and retrieve all the data. It provides about 90% cost saving than hot storage. And for less frequently accessed data, you can store them in EBS or local storage or S3. And please take into balance between cost and performance into consideration to determine which storage to store the data. And by the way, if you store in S3, you cannot change a document but delete by index. The OpenSearch offers the advanced full-text search capabilities. In addition to simply matching the keywords, you can utilize more complex query and analysis. The OpenSearch offers the ranking evaluation, the phrases search, the proximity search, the fuzzy search, and the language-based search. These full-text search feature enhance the search capability of website and application, allowing users to find the information they need more efficiently. And next, I'm going to introduce Amazon SageMaker Integrated Development Environment for AI and Machine Learning. Amazon SageMaker is a free managed service to build, train, and deploy machine learning models. In the building phase, the SageMaker provides a Jupyter notebook that the data science can use to prepare and process data and to experiment with the model prototypes. It offers the collection of high-performance algorithms optimized for its platform, so you don't have to write them from scratch. And it supports the popular machine learning and deep learning frameworks like TensorFlow, PyTorch, MXNet, allowing data scientists to use familiar tools. In the training phase, the SageMaker automates the tuning of the model parameter to get the best out of your model, a process often referred to hyperparameter optimization. And it can handle large datasets and perform the distributed training using the multiple instances. In the machine learning workflow, you need to define the problem and collect the data. And this data must be cleaned and explored with the relevant feature engineered. And subsequently, the split data into the training and test set, and then select the suitable model, and train it, and evaluate its performance on the test set. And you might need to tune the hyperparameters for optimization. And once satisfied with the model performance, deploy it. And it's crucial to continuously monitor for the model, ensuring its accuracy and relevances are maintained over time. And machine learning can be categorized into supervised learning and unsupervised learning. And within these categories, there are the classification and the regression and the clustering. In the field of AI, they heavily utilize mathematical technology, including the statistics and probability. While the data analytics exam does not test on these topics, but for machine learning specialty exam will include questions of these models. For those considering the future career in AI, it's highly recommended to begin with the content here and further dive into AI theories. And this is a list of SageMaker features and the function covered by each. You don't have to memorize all the features listed here, but from the practical standpoint, it would be good to know. And next, I will describe the Amazon QuickSight. Amazon QuickSight is a business intelligence tool. It imports data from multiple sources and processes and filters into the appropriate format, and then produces the dashboard and the report for the management review. It offers a wide range of graph and report functionalities, allowing for the visualization of the data analysis result. It supports data sources not only from AWS, but also from the third-party tools below. The QuickSight has a high scalability. It caters to users in the hundreds of thousands without the need server infrastructure management due to its serverless architecture. With its in-memory database, Spice, it allows for rapid analysis without extending stress on the data sources. With machine learning insight, it can perform anomaly detection and analysis. And also, by integrating with SageMaker, you can visualize the data using models they have created themselves. In order to use QuickSight, you need to create an account. The pricing includes the Standard and Enterprise. The Enterprise editions offer more features, and you can create an author as well as a leader. In addition, you can use the Enterprise queue, which you can use QuickSight queue. With QuickSight queue, it provides the functionality through the natural language processing. With QuickSight queue, you can ask a question in natural language and get appropriate tools. For example, if you type "show me item with most revenue last week," and then the QuickSight queue will interpret the wording and return the bar chart with the data. And you can use in-memory engine called SPICE. The SPICE stands for Super Fast Parallel In-Memory Calculation Engine. It is the in-memory calculation engine developed by Amazon. It automatically scales based on the data processing and analysis demand. It's built to execute calculation parallelly across multiple cores, which means it can handle large data efficiently by distributing the workload. And you can utilize a variety of graph and chart for QuickSight. And these are some examples. If we want to visualize the time series data, the line chart, bar graph, combo chart, and the waterfall chart are suitable. And for comparison visualization, you can opt for horizontal bar chart, pie chart, horizontal stack bar chart, the horizontal stack 100% bar chart, the heat map, the tree map, the scatter and the bubble chart, and the visualized data plotted on the maps. If you want the correlation, the scatter map is appropriate. If you want to visualize the distribution data, the histogram and the box and the whisker diagram are suitable. And therefore, the QuickSight supports many types of graph and chart. You can use these tools to visualize data according to various use cases. And lastly, I'm going to introduce security domain. In this chapter, I will explain IAM, data encryption services, data governance tools, and monitoring and logging tools. AWS offers various security services, and with IAM, you can handle ID-based access control. You can manage the permissions for IAM user and IAM groups, making sure each identity has only the permissions they need. And in terms of network security, the VPC allows for network isolation. By setting up a firewall, you can manage access based on the criteria like IP addresses, protocol, and locations. The encryption for data at rest, it is crucial in data analysis. The AWS provides solutions like KMS and CloudHMS for this. And lastly, AWS has services for data protection and detection of sensitive data, such as Amazon Macie and Amazon Detective. And next, I'm going to introduce AWS IAM. AWS Identity and Access Management IAM helps you securely control access to AWS resources. With IAM, you can centrally manage users security credentials, and permissions that determine which AWS resources users and applications can access. The IAM component includes policies, users, the groups, and roles. The IAM policy is an object that defines the permissions. It attached to an identity or resources, determining what actions are allowed or denied. It is written in JSON format and can be granular, specifying the permission types, resources, and conditions. IAM users are entities that you can create that represent the person or service who use them to interact with AWS. IAM users consist of a name, password to sign into the management console, and up to 2 access keys that can be used with API. IAM group is a collection of IAM users that you can use the groups to specify the permissions for multiple users, and which can make it easier to manage the permissions for those users. The IAM role is a secure way to delegate the permissions that doesn't involve the sharing the security credential. You can use role to delegate access to users, applications, or services that don't normally have access to your AWS resources. For IAM users authentication, there are a combination of an ID and password and a key pair consisting of the access key and the secret key. By enabling the MFA, you can enhance the security. While the ID and the password are memory-based information, the key pair has a risk of leakage. Thus, the AWS best practice suggests minimizing the use of the access keys and adopting the alternative authentication method. Additionally, they recommend the guidelines for managing key pairs. They follow the principle of least privilege. They avoid hard-coding the key pair. They set them as an environment variable instead. They use IAM roles or cognate as alternative. They implement the IP address restriction for users with a configured key pair. They perform periodic key rotations and periodically check the usage of access key. By assigning the permission to IAM groups and adding IAM user to them, the hassle of granting the permission to individual IAM users can be avoided, and the risk of excess or insufficient permissions can be reduced. This is an example of IAM policy in JSON format. The version is set to 2012-10-17, and this remains constant. Under the statement, you can set multiple conditions. In actual IAM policy, since there are instances where multiple permissions need to be defined, you will see a series of curly braces following the statement. SID allows you to set an arbitrary identifier, and in effect, you write either allow or deny. For action, you specify the target API actions. There are the various kinds of APIs for each resources, allowing you to define them in detail. In this example, an asterisk is used, which means to allow any actions. However, in actual practice, it is advisable not to use asterisk excessively. Utilizing the asterisk would mean the granting permission to any action, which goes against the principle of the least privilege. Conversely, if you specify the asterisk and set effect to deny, it would deny all actions. For resource, you describe the target resource here. Again, an asterisk is used here. It implying the permissions for any resource. And under conditions, you can describe the conditional clause. And additionally, where you see ARN stand for Amazon Resource Name, which is a unique identifier for AWS resources. I will introduce more detail about the conditions. Within the condition field, you can set detailed condition. The table here is a summary of conditions. The string equals determines if the strings are an exact match. For example, it determines if the resource name or tag name matches. The similar condition to string equals are string like and not equals. The numeric equals determine if the numerous matches. The similar condition to numeric equals are numeric not equal and numeric greater than. The bool can define binary condition for true and false. For example, a condition can be defined to be valid only when encrypted communication is enabled. ARN equals determine if the ARN matches. Data equals determine if data match. And next, I'm going to introduce the classification of IAM policy, which can be either identity-based or resource-based. The identity-based policy is attached to an identity, like a user, group, or role. It grants the permission to the identity to perform the specific actions on specific resources. There are two types in identity-based policy: the managed policy, which is created and managed by AWS or the user, and the inline policies. It is specific to single identity. The resource-based policy is attached to the resource, like an S3 and SNS topic. It grants specific identities permission to perform specific action on the resource. It often includes a principal element to specify who is allowed or denied access. The resource-based policy typically includes a principal element that specifies who is allowed or denied access, while identity-based policies are inherently tied to the entity they are attached to and do not have a principal element. I have talked about IAM policy, and I want to point out some common patterns for resource-based policies. If you forget to set the policy, you may gonna get the permission errors. The services like S3 as the origin of the CloudFront, the Lambda, and the SQS are often used with many other services. And especially Lambda and SQS work best when combined with other services. You need to set the proper policies. And next, I will discuss policy provided by the other services, similar to IAM policies. Permissions boundary is a managed policy that sets the maximum permission a user or role can have. It's useful for use cases where an IAM entity needs to create role or users but should not grant them through admin rights. The permission boundary limits the permission the new role or user can get. The Service Control Policy, or SCP, is exclusive to organizations with AWS organizations. It applies to account or organizational unit within the organization. The SCP defines the maximum permission entity within the account can have, effectively acting as a guardrail. For example, even if an IAM user in the account has full S3 access, an SCP can deny that permissions. The session policies is the path when assuming a role or federated user session. It limits permission for the session. It interacts with identity-based and resource-based policy to determine the effective permissions. It cannot grant more permission than those policy, but can further restrict them. I'm going to introduce the use cases involving the multiple account, and this is a little bit complicated scenario. This image shows the application on an EC2 instance executing the action on S3. On the left side, you see the cross-account setup, while the right side represents the single account setup. For multiple accounts, the identity executing the action and the resource receiving the action belong to separate accounts. In this scenario, only the action allowed by the policy attached to both identity and the resource are valid. For example, this is an AND condition. In this example, only getObject is valid. And for single account, any action attached to either the identity resources become valid, creating an OR condition. In a multi-account scenario, if we want to allow a specific action, you must explicitly state allow in both the identities and the resource policy. In contrast, for a single account, if we want to deny specific action, you must explicitly state denied. And this example presents the simple scenario with one identity and one resource across two accounts. However, in real world, the large-scale system, there can be multiple accounts and multiple resources, making policy management more complex. When sharing resources across the multiple accounts, the tools like the Resource Access Manager can simplify the process of resource sharing. And next is the permission boundary. The permission boundary is an advanced policy that sets the maximum permission that an identity-based policy can grant to IAM entity, such as a user or role. Essentially, it's a way to put an upper limit or boundary on the permission that can be assigned to the IAM entity. The permissions boundary are useful in the scenario where you have decentralized IAM administration. For example, in large organizations, the central cloud team may wish to delegate the IAM responsibility to departmental teams, but to still retain a control over the maximum permission that can be granted. The service control policy in AWS organization are similar to permission boundary. The SCP are used to restrict permission inherited from the parent unit within the organization hierarchy. For example, while the parent unit might have permission to launch all EC2 instances, the child unit might be restricted from launching a certain EC2 instances only. On the other hand, IAM permission boundaries are defined for individual IAM users and the roles to limit the maximum permission those entities can have. The policy definition for both are described using JSON. The next is switch role. The switch role refers to the process of switching from a specific IAM user to different IAM users. It is possible to configure the switch role across the accounts, allowing for the setting of IAM user in one account and IAM role in another account. When granting a role from different account, the user requests the permissions, and the other account grants the role with those permissions. And based on the granted permissions, the user can access resource in other account. The next up is the confused deputy problem, and it is a little bit complicated problem. The confused deputy problem refers to the security issue where an entity that does not have permission to execute an action can compel an entity with a higher privilege to execute that action. For example, when using the services of Example Corp, you provide the ARN of AWS example role to Example Corporation. Using that role's ARN, Example Corp retrieves the temporary security credential necessary to access resources in your AWS account. This means you trust Example Corporation to act as deputy on your behalf. But meanwhile, another user, the user B, tries to utilize the services of Example Corp and provides the ARN of AWS 1 example role for Example Corp's use. User B might have acquired AWS 1 example role by some means. When user B requests Example Corp for access to their AWS resources, Example Corp uses the AWS 1 example role to access resources in your AWS account. This is confused deputy problem. To avoid this problem, when Example Corp assumes the AWS 1 example role, they include your external ID in the Assume Role API call. They confirm that this external ID matches the trust policy of the role before executing the Assume Role API call. Afterward, Example Corporation obtains the temporary security credential required to access resources in your AWS account. When specifying the multiple resources, use wildcard in the global condition context key to indicate unknown parts of ARN. They include incident record in source ARN. Now I'm going to show you how to set up IAM policy which have external ID to avoid confused deputy problem. And first, you create an external role in your AWS account, AWS 1. The trust policy for this role looks as follows. This trust policy allows the assume role request from Example Corporation. And this permission is granted only when the STS external ID matches 12345. At the next Example Corporation assume this role using a command like the one shown, retrieving a temporary credential. Through this command, Example Corporation assumes the example role and obtain temporary credential to access resources in the AWS 1 account. And then you specify the condition section to restrict requests from the specific AWS resources. For example, you might use this to allow requests only from a particular S3 bucket. And in this example, the AWS source IAN specify a particular incident record from the SSM Incident Manager, permitting the request from the specified incident record. This policy allows the request from SSM incident that comes from any incident record associated with the My Response Plan response plan. And this above representing the method to avoid the confused deputy problem. Finally, these are our IAM security best practices. The most of the information listed here is the same information that I have provided in this course. I recommend that you read them if you have time. Next, I'm going to introduce AWS SDS. AWS SDS Security Token Service allows for the creation and provision of trusted user with temporary security credential to control access to AWS resources. Unlike regular credential, these temporary credentials can have a set expiration ranging from a few minutes to several hours. And additionally, these credentials are not stored with the user but are dynamically generated and provided. Once these credentials expire, access is no longer granted. Through the assume role action in AWS SDS, you can obtain and assign temporary credentials from IAM users. When a role requests to assume role, the SDS issues and grants temporary credential. And I'm going to introduce the flow of the temporary authentication using SDS between different accounts. In this example, the account A is trying to access a resource in account B. And first, here is the example of the command to obtain the temporary security credential. The account A assumes a role named my role. And then account B will return a response like this. The credential field with this response contains the temporary access key, the secret access key, and the session token. The account A uses this credential information to access account B's resources. Within the credential, you can set the expiration, and once the expiration date has passed, this credential becomes invalid. And in this example, if a user in A wants to access a resource in account B, the role is created in account B. The account A is specified in the trust policy for that role, and the user in account A can assume the role. The role existing in the account B, but is assumed by user in account A. When accessing account B resources from account A, includes the temporary authentication information obtained earlier in the CLI environment variable. The evaluation logic tree allows you to comprehensively review the policies introduced so far. There are various types of the policy, and they include both explicit and implicit permission and denies, and which aid in determining the final effective actions. If there is an explicit deny, then that action will be denied. If an SCP is set and there is no allow, then it implicitly results in a deny. Following this flow, you can evaluate the policy based on whether they are resource-based or identity-based, and if the permission boundaries are set, or if there is the permission policy, it's giving the comprehensive evaluation. And next, I'm going to introduce Apache Ranger. The Apache Ranger is an open source framework designed to enable, monitor, and manage comprehensive data security across the Hadoop platform. It provides the centralized security administration to manage and enforce security policies consistently across the Hadoop components. The Apache Ranger policies are often represented in JSON format, especially when interacting with the Ranger admin REST API. When you export, import, or manage policy programmatically, they are typically handled as JSON objects. And these are the components of the JSON format of Apache Ranger policy. The policy name typically used for identification and management purposes. And the resource name specifies the resource that the policy is applied to HDFS folder path. The policy item is the section that contains the detail of the access permission. It includes the accesses, which defines the types of accessing being granted. And here, the read access is being granted in this example. And the list of users who are granted the permission specified in the accesses section. And also list of the user groups who are granted the permission specified in the accesses section. And in addition, you can add a condition and delegate the admin, which determines if the users or groups specified in the policy can further delegate the admin rights. The same as policy item, you can define the deny policy item. In addition, you can activate the policy or not. The function of Apache Ranger overlaps the IAM policy. The table shows the detail of differences. The Apache Ranger is a security framework tailored for fine-grained access control within the Hadoop ecosystem, while IAM is the service designed for broad access management across AWS cloud services. And next, I'm going to introduce AWS KMS. The AWS KMS, Key Management Service, is a managed service designed to simplify the creation and the control of encryption keys used for data protection. It manages the CMK, the facilitating generation, encryption, and the decryption of the key. The key used to encrypt data are called CDK, Customer Data Key. The CDKs are encrypted using the CMK. The KMS supports customer-managed CMK created and managed by AWS users, and the AWS managed CMK created and managed by AWS. There are two main encryption methods. The symmetric encryption, which uses the single key for both encryption and decryption, and the asymmetric encryption, which uses a public key and a private key pair for encryption and decryption, respectively. The terms secret key cryptography and public key cryptography might be more commonly recognized. The asymmetric encryption is a newer service and is more secure. Here, the image shows the asymmetric encryption. First, the target file is encrypted using the encryption key. And for security reason, the encryption key itself is encrypted. During the decryption, the key is first decrypted. The decrypted key is then used to decrypt the file. It is risky to use the same key for an extended period due to the potential compromises and leaks, and therefore it recommends to rotate the key material once every 365 days. For example, the default rotation period for S3's AWS managed CMK is 3 years. If you need a more frequent rotation, you consider using the customer-managed CMK. Even after key rotation, the previous key materials are retained, ensuring that you can still decrypt data. Only the key materials undergoes rotation. Other properties such as the key ID, key ARN, the policy, and the permission remain unchanged. If rotation within a year is desired, you can employ manual rotation for shorter rotation cycle. The key and the key material are different concepts. The key is the logical entity for data encryption and the digital signature within KMS. A CMK has associated metadata such as unique key ID, ARN, creation date, and description. On the other hand, the key materials refer to the secure binary representation of the encryption key itself. It is the sequence of the byte used for the actual encryption or decryption. With KMS, you can choose the key material generated inside KMS, where the generation and the use of the key materials takes place inside AWS. You can enable, disable, and delete the CMK. However, once a key is deleted, it cannot be recovered forever, which poses a risk of losing the ability to decrypt the data encrypted with that key. And therefore, you think a key is no longer needed, it's first logically removed and then physically deleted after a waiting period of 7 to 30 days. During this waiting period, if the key is used by someone, it will be detected by CloudWatch and CloudTrail. It is recommended to disable unnecessary keys first rather than deleting them outright. You can set key policy, resource-based policy for KMS. The key policy can be used to control access to the CMK. The key policy can be used in conjunction with IAM policy, where IAM policy controls access to the users and the roles, and the key policy controls access to CMK. In other words, key policy is the resource-based policy. The key policy can be described in the JSON format as shown below here. By specifying the action field in the key policy, you can restrict the permissions. This sample on the left is the action of the key administrator. The key administrator can manage key creation, activation, deactivation, the deletion, the scheduling, and so on. And on the right are example of the key user actions. The key user can encrypt and decrypt using KMS and generate the data key. Next, I'm going to introduce AWS Secrets Manager. The AWS Secrets Manager is a centralized service that manages the lifecycle of the database credential and the secret information such as password. Using the Secret Manager, you can retrieve the secret information via API and can it to the authentication and the server setup. The secret rotation is supported and the rotation is performed by Lambda function. If secret information is included in the application code, there is a risk of leaking the event of the incident. In addition, you have to update the password within the application code, which can lead to high cost. It is recommended that the secrets not to be embedded in the application code, but be stored in the Secret Manager. The secret manager and the parameter store have some overlap in the functionality. I'm going to introduce the differences. The secret manager is primarily designed for managed and rotating the secret like a database credential, API key, and other sensitive information. The parameter store is the part of the system manager. It is designed for storing the hierarchical configuration data, including the plain text or encrypted strings such as password, database strings, and license code. The secret manager has built-in the functionality for automatic rotation, secret for the supported database. The parameter store does not have automatic rotation. The rotation logic, if needed, must be implemented by the manually. The secret manager generally has higher cost due to its automatic secret rotation feature and other advanced feature. The parameter store offers a free tier with limit on throughput and parameter counts, but also has an advanced tier with more features, such as increased throughput and parameter history. The secret manager is deeply integration with RDS, Redshift, and DocumentDB for secret rotation. The parameter store has more integration, the point with the other system manager capability and services. And next, I'm going to introduce the AWS Certificate Manager. The AWS Certificate Manager, or HCM, create, store, and update the SSL TLS certification and the keys that protect website and applications. User-owned or user-issued certification can be imported and registered in CloudFront, Elastic Load Balancing, and API Gateway. The certificate ownership is verified by email authentication and CNAME authentication. The HCM does not issue a site shield, so a third-party tool must be used if necessary. The HCM's private CA will create the certificate authority and issue certificate for authentication of users and application devices. The HCM provides the domain validation certificate. If we want to use the extended validation or organization validation certificate, use an external issuing authority and import them into HCM. However, imported certificates are not automatically renewed and must be renewed manually. Next, I'm going to introduce data governance tools, the Meishi, GuardDuty, Detective, and Artifact. The Amazon Meishi detects the confidential data stored in S3 bucket. It identifies the pattern of sensitive information using the machine learning method. You can easily get started with Enable Meishi from the Meishi console menu. The results detected by Meishi are encrypted by KMS. The Meishi help you comply with the compliance requirements as shown here. The Amazon Meishi includes the ability to detect confidential data, such as credit card numbers, but it does not have the capability to encrypt or mask data. By using S3 server-side encryption, SSE, the client-side encryption, and the AWS KMS, you can meet the data protection requirement necessary for PCI DSS compliance. Next up is GuardDuty. Amazon GuardDuty is a service that analyzes the storage and the logging service to extract data that poses a threat. It uses the machine learning techniques for automatic detection. It targets logs such as CloudTrail, S3, VPC flow logs, and DNS query logs. By simply clicking on the Enable Guard Duty, you can start using it. The detected results are sent to CloudWatch event, and the notification can be made via SNS. The example of extracted threat intelligence includes the credential leak to S3, abnormal data access, suspicious login, and malicious API call, and so on. When used in conjunction with Amazon Detective, it provides the context, metadata, and the results of the security event for the resources and help in identifying the root cause. It scans the EBS for behavior suspected of the malware. By integrating with the Security Hub and the Event Bridge, the threat intelligence can be transmitted to operational tools. The Amazon Detective is the service that automatically collects logs from the various services, and using the machine learning and statistical analysis, it conducts detailed investigation. It can integrate with GuardDuty, Security Hub, the CloudTrail logs, and the VPC flow log. You can search logs such as GuardDuty findings, EC2 instance, AWS account, IP addresses, and IAM roles. The use cases from the Amazon Detective includes the IAM user access from unusual IP addresses. The multiple abnormal EC2 instances were launched, potentially for purposes like coin mining. The monitoring of API call successes and failure. A significant increase in failure could indicate a potential breach, and the user exhibits the behavior that deviate from the unusual pattern. The billing is based on the data ingested from CloudTrail, VPC flow logs, and GuardDuty. AWS Artifact is a service that provides on-demand access to security, compliance documentation, and the AWS contract. It can be accessed from the console, offering both artifact agreement and artifact report. The artifact agreement allows users to manage contract within an account, and you can centrally view current contract details, initiate a new contract, or terminate unnecessary agreement. And these are individual account agreement and organization-wide the organization agreement. The organization agreement can be used when integrated with AWS organizations. The artifact report is a service where users can receive reports related to the compliance audit. It provides the evaluation report on whether the organization's compliance is appropriate. In addition to AWS evaluation, it also supports assessment by third-party entities. Both report and agreement are available at no additional cost. These are just for your reference. These are some of the agreements that the artifact agreement support. And this is also just for your reference. Next here is a report that can be referenced to in the artifact report. And although not directly included in the AWS certification exam, I think it's good to know about them as a general knowledge as the information security. And next, I'm going to introduce the monitoring and the logging tools. The first one is the Amazon CloudWatch. The Amazon CloudWatch is an integrated operational monitoring service. It has a very large number of features and can monitor all AWS services, and making it the most widely used monitoring tool. The CloudWatch monitors the AWS resources in operation and has the function such as the triggering the resources status changes, to generate actions and alert. An overview of CloudWatch functionality is here. The CloudWatch collects the logs and metrics and generate alarm when they exceed the threshold, and notifies the buyer SNS and execute the necessary action in conjunction with the Lambda functions. The CloudWatch logs captures application and server logs. It also has the function for analyzing the tool. You can configure log retention period from 1 day to unlimited, which can be used for auditing purposes. The logs can be filtered and searched by the specific strings to see how many errors have occurred. Here is a sample query that streams the VPC flow logs to CloudWatch and extracts them for a specific time period and address. Usually, log record can be in the thousands or tens of thousands, so filter appropriately to extract only the information you need. The metrics is a grouping of system health and performance information and a measurement for specific time period. There are metrics that are automatically obtained from the various AWS resources and metrics via APIs. The standard metrics such as CPU usage, HTTP request, disk and usage, as well as custom metrics can be specified. The logs and metrics can be obtained from on-premise resources as well as AWS resources. The metrics can be obtained by installing the CloudWatch agent on a Linux and Windows server. And next is the CloudWatch alarm. The CloudWatch alarms are generated when preset thresholds are exceeded or when anomalies are detected. Triggering by the alarm, the notification can be sent via SNS and the action can be taken. You can configure statics and the duration of alarm. And the metrics of alarm include OK, alarm, and insufficient data. The CloudWatch event is the feature that detects changes in the status of AWS resources, capable of streaming the information in real time. With CloudWatch event, based on the event and the rules, you can trigger action on specified target. The event sources can be categorized into the schedule and event. For example, you can define an event to execute an action on a specific day of the week, or trigger an action when the metrics of a given resource exceed a particular threshold. The target can be defined using the rate or coulomb. The CloudWatch event often works in the tandem with the Lambda function, allowing for the process where the certain event triggers the execution of another AWS resource. And next, I'm going to introduce AWS CloudTrail. AWS CloudTrail is a service that logs user activity and API operation from the CLI, SDK, and console. It's possible to record the trail of who did what and when. The logs that can be obtained with CloudTrail include management events such as security group setting, device registration, and data event such as operation on S3 bucket, execution of Lambda function. When CloudTrail Insight is enabled, the anomalous activity logs are detected and displayed. And this is the sample trail of API call of EC2 instance. And you can store the past 90 days trail for free for long-term storage used with S3 or other storage services. The S3 trays are encrypted with SSE S3. If you need to use your own keys, you can use KMS. If you want to avoid changing or deleting the trail for auditing purpose, it is recommended to take the following measures. The use KMS control access to KMS with IAM, the use S3 bucket policy and IAM policy, the set up MFA delete to prevent the accidental deletion, the create the dedicated account for trail storage, set up the digest file to keep a hash value of the trail, and this will serve as an evidence file that the trail has not been tampered with. The next and lastly, I'm going to introduce AWS Config. The AWS Config is a service to log configuration changes of AWS resources. It is used for change management and the acquisition of change history. You can check the history of who made what changes and when and to what extent in the event of operational incident. Example of changes history that can be retrieved with the config includes the configuration changes to AWS resources, software configuration changes on EC2 instance, and the resource relationship, such as changes to security groups associations. You can also use query to retrieve the history under specific conditions. The config rules features allows you to automate the evaluation of recorded configuration against the desired configurations. With config rules, you can assess how well your resources configuration align with the external compliance standards and the internal best practice and other guidelines. There are two primary types of config rules. The AWS managed rules will predefined, customizable rules that AWS provides. For many AWS services, AWS provides a set of managed rules that correspond to the common best practice for those services. And the custom managed rules allows you to define custom compliance rules for your AWS resources. It's particularly used for unique use cases that are not covered by AWS managed rules. In conclusion, in the summary of Chapter 4, I will introduce the pricing calculator, support plan, marketplace, and learning resources. AWS Pricing Calculator is a tool to help users estimate their cost for various AWS services. You can input your expected resources usage, such as the number of EC2 instances or the amount of S3 storage, and the calculator will provide the detailed breakdown. And you can estimate cost, save, and share the estimate and get optimization recommendation. For your reference, the above figure represents the pricing trends for the EC2 and S3. The prices of cloud have been going down over the years. Because of the competition between the cloud providers like AWS, Google, and Microsoft, and the improvement in technology, these prices are expected to keep dropping. The prices and the services from the all cloud providers change often, so it's important to stay updated. AWS Partner Network (APN) is a global program whose purpose is to identify AWS partners who can assist clients in designing, architecting, building, migrating, and managing workloads and applications on AWS. and to facilitate their engagement with clients. The APN consists of the following two types of the partner. Consulting partner is the professional service firms that help clients design, architect, build, migrate, and manage their workloads and applications on AWS. They offer services like infrastructure migration, application development, and managed services. Technology partner is independent software vendors that develop and offer software solutions optimized for use on AWS. They provide the services such as software development kits, APIs, and other tools to assist in integration of clients' applications with AWS services. AWS partners in the APN program can get benefits, including the training and the certification program, the marketing and the sales support, the technical support, and access to AWS resources. This is a list of AWS support plans. By opting for the pet plan, you can receive more comprehensive support. The further to the right you go, the more extensive support becomes, including the technical support from the experts called TAMs, and the faster response times. The AWS Repost is a QA community where members can post questions, and the participating members of the community provide answers. AWS marketplaces allow the clients to search for, compare, and purchase software and services from third-party vendors. The client can utilize AWS Marketplace to discover solutions tailored to their specific needs. For example, in EC2, you can obtain AMI, where clients can purchase the matching images with software from the third-party vendors on the marketplace. And in the last, here is optional AWS learning resources. While I've covered what's on the exam, just check the official documentation and white papers for more details. The AWS also has the training site Skill Builder with sample questions. And the AWS announced new service at events like re:Invent and the AWS Summit. If you use AWS often for work, it's good to attend this event. With that, we've come to the end of the Udemy course. I hope the content has been valuable to your learning journey. And thank you for dedicating your time with me, and I wish you continued success in your endeavors. Thank you for watching all this time.